Guys, can you hear me now?
Loud and clear.
Okay, I'm so sorry. So let me just go straight ahead and I'll be quick. So, last week we worked on the understanding of the data set, and this week we are doing transforming the data set. Um, and then this is the transformation overview. So what we want to do is we'd get familiar with our data sets, and then we'd investigate our data sets by year representation, and then investigate by annual rate of change, investigate by access by area, investigate by access by region, and then we work on our multiple choice. Um, so so this is still just more like the overview. Um, okay, so like I said, it's quite similar to the previous data we worked on, which is the WHO UNICEF GMP that estimates the use of water on different areas and country. But for this particular one, rather than just 2000, we are looking at a year period of 2000 to 2020. So what they first want us to do, which is the number one, is for us to import our data. Um, Let me create a new file. Okay. So what they want us to do is import our data. So to import our data, we come to File on the menu bar. We'll click on Import. We'll go to Upload, click on Browse, and then this is my data. And the reason why I have it here is because I had already downloaded the data. So I'll click here, open. Now it's asking us what it should do with data. Should it create a new spreadsheet entirely? Should it insert a new sheet? Should it replace the data sheet? So now, since it's a new spreadsheet I just opened, I'll click on replace. But peradventure, if it was the initial spreadsheet I was working with and I needed to import, rather than me, I'll just click on probably create a new spreadsheet entirely or create a new sheet if I mean if they are part of the same um, file. So yeah, I'll click on replace spreadsheet. Now you can see from here that it says a CSV file. So that's the delimiter. So I know that the separator type is a comma. So I'll click on comma and then I'll import my data. All right, so to import my data, the first thing I do is I try to freeze, I bolden my column names. So I'll bold it just so I can separate it from the data itself. And then I freeze it. Now to freeze it, you just, same way I highlighted the row, sometimes it might be here you need to freeze. It might just be column A you need to freeze. Other time it might be two columns, it might be two rows. But for this one, it's just this first row I want to freeze. So I'll just click on the first row. I'll come to view on the menu bar, and then I'll click on freeze and one row. So anytime I move downwards or I move upwards, that is still, in place. All right, so I've what's called imported my data. So we need to get familiar with our data and see how our data is different from the previous one. If you can remember the initial data set we worked on, right, we had two categorical datas and we had 12 numeric data. So categorical data being names. So we had name here and then we had income group here, which was the higher income group, lower income group. But for this one, you can see that rather than the income group, we're having year, right? And then we're having year. Still the pop n we had in the first data, pop u, what base n, what live n, all are still here. So the major difference is we removed or we replaced the income group with the year column. All right, let's go back to our data. So it says, considering that the data set title includes 2020, can we confirm that our data set does represent this time period? Okay, so
Sorry to cut you, Mr. Olatunde, sorry.
All right.
I did want to ask, how do we get the data, especially the one that you uploaded on your Excel sheet?
Okay, so if you are on your Athena data set, um, you come to this integrated project, you click on it, okay, and then you scroll up. So up here, you can see download train and then download additional files. So those files you saw there, I had to click here. I downloaded additional file and this is the file. So I would have to extract this file because it's currently in a zip file. And to extract it, based off of my system, I just right click and then I click on extract all and then I
Okay.
extract.
Okay. Okay.
All right,
Thank you for that. Thank you so much. You can carry on.
you're welcome. So, so what they want us to do now is, considering our data sets, um, they want, how can we confirm that our data set does represent this time period, meaning that our data set is actually within 2000 to 2020, right? So how can we do this? There are several ways which we can do this. Um, so I'll go back to my data set. So one of the ways I could do it, which is this one is actually what I like doing the most if I want to understand what a column or row or whatnot is about. So I'll right click, I'll look for column stats. So I click on column stats, and from column stats, I could get more information. So just by looking at this now, I can tell that in this year column, we have um, 2015, 2016, 2017, 2018, 2019, and 2020 represented. And you can easily see that 2015 as was shown 232 times when you click on this, when you hover around this. And you can see that 2020 was shown 214 times. And without anybody even explaining, you can tell that these ones here are literally are more like outliers, right? Though we still have to do more investigation to understand if they are outliers or whatnot. But you can tell that most of the data were collected in 2015 and then 2020, right? So now, and our data, it says that we need to confirm if our it was collected between 2000 and 2020. So this is 15 and 20. So obviously it means our data was actually collected within that time period. Another way we could do that is we could just probably do like a mean. We would look for the minimum. Still, if you do the on this column stats, you can still see minimum value there, but you could open a different spreadsheet. Let me open a different spreadsheet to just create my minimum value. So we can open a different spreadsheet to create that my minimum value. And to create minimum, you just have to mean just so to know if the minimum value is within that 20, if it's within that 2000 to 2020. So I'll just click on equal to mean. I don't have to type it completely. It brings Google just brings it out. The spreadsheet brings it out. So I'll just click here and then come. I can click on this comma to get more understanding about what the formula is about. So it states that I can add value one, value two, to whatever number of value I want to add. Well, since I'm checking something from this sheet, so I'll just come to this sheet and then I'll click on column B because I want to know the minimum value in column B. Then I'll click on enter. So you can see that the minimum value here is 2015, while the maximum value, I mean, since it's still the same column, I don't need to do too much. I'll just copy, Ctrl C, and then I'll paste it here. Ctrl V, but I'll change this to maximum because we are dealing with the maximum now. So maximum value, and then we click on enter. So this is 2020. So we can tell now that, I mean, this is already answering our question. I mean, those two methods I just did can answer our question, which is how do we confirm that the data set does represent the time period? So we'll move to the other one. It says, how do we know if the difference between years per country are similar? So I think this one will still would sit in front. So let's just carry on. So yeah, now that we've understood our data, we've seen how different our data is from the previous one. We understand that we have a categorical data here, which is the name of countries. We have year here, which is the year the data was uploaded. And then we have POP-N. Now understanding earlier on the population of that nation, of this country. POP-U, this is the urban population in percentage. What base N, that's the basic access in the nation, basic access to water in the nation, also in percentage. And then there's what lim N, what unim N, and what so N. So how the same way we have what N, we also have for rural and we have for urban, and they are all in percentage. So now that we've done that, we'll now investigate the year representation, which is answering this question that was here. How do we tell the different years per country are similar? So now, during which years was this data recorded? That's the first question you want us to answer. And then what is the average number of years between the data collection? So we know, most countries, what is the difference in their years? That's what this is want us to know, to ask. And this is asking during which years was this data collected? This first question, from our column stats, we can already say that it was collected in 2015 and 2020, right? But we'll still go ahead and continue to do. So what do they want us to do? So they want us to observe which years represented for which country, and then they want us to sort both by names and year. So they want us to know this country, what years are represented? 2015, 2020, what year was the data collected? 2020, 2015, 2016, 2017. So they want us to do that. So now, if we sort without considering the row containing column names, they are sorted, and it might end up where we don't expect. So to avoid this, we right click on the row one and then click on view and then more action, and then we freeze up to row one. So we've actually done this already. So what they are saying is, for example, let me just unfreeze first. Let me unfreeze. So what they want us to do, they want us to sort, and they want us to sort by name and by year, meaning they want us to have names of countries here, and then they want it to be accordingly, meaning if we have Croatia here, we have all the Croatias before we get to Argentina. If we have Argentina, we have all the Argentina before we get to Greece, right? And while we're having all of them, we're also seeing the years, and then they also want us to sort these years as well. So the years has to be, rather than 2020 year, to be 2015 moving to 2020. You understand? So like that. So they want it to be in ascending order as well, right? So if we do that without having to, so without freezing this, let me just show you an example. We come here, we come to the data, we come to sort range, advanced range sorting option, and then we okay, yes, so we sort by name first, and then we sort by year, then we sort. Oh, okay, it's staying fine. All right, so the thing is, it was because I clicked on what's this thing again? I clicked on this data as header row, right? So if I didn't click on data as header row, it would have sorted everything individually, and even the names would have been sorted, like even the column names would have been sorted. So what they want us to do, let me just freeze it back. So what they want us to do is they want us to click on the entire sheet, select the entire sheet, come to data. So we sort range. Now, because we're not sorting just one column, we would have to use the advanced sorting option. So in the advanced sorting option, we would click on data as header rows, right? So once we click on data as header rows, it would show us the column names of each of those columns. So you can see name column, year column, pop n column, pop q column, And you can see A to Z means ascending order, Z to A means descending order. So we've clicked here. And we already said we want to sort it by names first and then by years, right? So we've sorted by name. We'll have to add another sort column, which is the sort by year column. And then we sort. So now you can see that it's different from the first one. Initially, let me just control Z so that you could. Initially, we had Croatia, Argentina, but now we are sorting um, alphabetically, ascending order. So we have Afghanistan, Albania, and then you can see the years too. 2015 is coming first before 2020. So we've been able to sort our column by, or our sheet by name and then by years. All right, so what do they want us to do next? So they also said if we were to sort only by name or by year using the right sort or sort A to Z or Z to A, we wouldn't be sure whether we are considering both parameters. So we will rather use data sort range, advanced range sorting option, because we are now sorting on average and not the entire sheet. So we need to make sure that we select our entire data sheet and then we add two sorts, which is sort by column A, the name, like we did earlier on, and then sort by column B. And both of them were sorting in ascending order, A to Z. So the next thing said, at first glance, it seems like the data were not recorded for every year in each of the countries. So I mean, the way the data was named, it said 2020 to 2000 to 2020. So in your mind, you might be thinking we have data for 2000, 2001, 2002. Well, just by you scanning through, you can see that most of these countries, they appeared twice. And then from the column stats we did initially, you could see that most of the countries as well, they had, what's the word now? They had majority just two data. So it means they're appearing twice. So um, so back to what we were reading. So he said we want to look at the change over time. We will have to account for that. So how do we determine whether the data we collected, I mean, only selected twice per country? So how do we know if the data we collected, like if the data we sorted is showing just two countries, I mean, is representing a country twice, Afghanistan 2025 and 2015 and 2020, Albania. So we want to know if it's twice it's representing. There are still multiple ways we could do that. We could come here, we could filter, look at the filter. Oh, okay, not the filter, sorry. So still the column stats. We could come here, we click on column stats. You could see Afghanistan, Albania, and you can see that the number of counts is twice. We could just scroll to the end to see. You can see that every other one is twice. They're all appearing twice, twice, twice. So we could go like that. Except for Zimbabwe. Zimbabwe is appearing 4 times. So that's an outlier. That's something we would have to work on eventually. So now we can answer the question that yes, most of our data were actually represented twice. Right. So we move to the next. So now that we've been able to confirm that most of our data are appearing twice. So I mean they are all in the same SI unit. If our venture, well, most of it except from one, which is the Zimbabwe that's appearing 4 times. If it was a mixture of twice, 3 times, 4 times, we would have to do a different kind of manipulation just so we can, I mean, of transformation, just so we can, everything can be in the same SI unit. So this is just two. So the next thing they want us to do is to calculate the average difference in years for data entered per country. So we just want to know average, like for one country now, we want to, all the year difference, we want to do the average to know what's the difference between the year, like Afghanistan, for example, now you could see that the first one was collected 2015, the second one was collected 2020. So we want to do for all the years to know you can see that this is 5 years difference. So we want to know if majority of them is 5 years difference, meaning that or the same way this Afghanistan is 5 years, many of them too are 5 years difference. So that's what we want to know. But just by looking at it, you can see that this Anguilla has 2015 and 2017, same thing with Antigua. But majority of the data actually has 5 years. So we want to know the average, the average difference in years for. So how do we do that? So they want us to create a new column, and we should call the column ydiff. So ydiff means year difference. So from this first few rows in the sorted sheets, we assume we only have 2 entries per country, right? So theoretically, we can subtract the second year from the first year per country, and then we get our ydiff. So this is what they are saying. So they want us to since we've already arranged it um, ascending order. So it means they want us to subtract this one from, since we've already established that each of those countries appears twice. So they want us to subtract this one from this one, right? So that we can calculate our year difference. And we come down here again to subtract this one from this one, the same way, subtract this one from this one. So, and then to calculate our year difference. So let's go back. So it says we should use, okay, let's first create our ydiff. So to create our ydiff, column, Ctrl V, we bolted it as well. So since we are working on ydiff, I would hide all these ones that we're not using so that we can easily see them. So I highlighted it and then I right click. You can see this hide column, right? So what we need is basically these two for now, and because we want to calculate the year difference. So now to calculate the year difference, so to calculate the year difference basically is recalculating we minusing B3 from B2. That's column B row 3 from column B row 2, right? And we're doing the same way as we go down, minusing the second year from the first year. So that's what they want us to do. So let's just go straight and do it. So B3 minus B2, we click on enter. So we can autofill. So we can click here to autofill. So you're already seeing minus, 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 minus. So there's an issue with our this thing which we'll fix later. So let's continue. So they said, so use an if statement to only subtract 2 years in the country. To only subtract 2 years if the country in the name is the same for the next or for the new futures. If they are not the same, return an empty string. So we are assuming that per country, the text will be exactly the same. So what that means is they want us to subtract this one and this one, right? And before we can subtract this one from this one. We have to first confirm if these first two names here are actually the same. If they are not the same, we can't do that, right? So if they're not the same, they want us to bring out an empty string. So the kind of formula I would create would be, what it would do is to first confirm this A2 and A3, are they the same? Yes, if they are the same, it will come here, it will minus B3 from B2, give us our formula here. It will come down again, A4 and A3, are they the same? No, they are not the same. So since it's not the same, it will return an empty string. So that's what they want us to do, to return an empty. So once it's done with that, come down again. Albania and Albania, are they the same? Yes, they are the same. If they are the same, minus 2020 from 2015, and then give us our value year. So if we do that, we'll notice that we'll get year difference here. Would not have a year difference here because obviously Afghanistan and Albania are not the same country. So it will bring an empty string here, a blank sheet, and then come here to minus, minus. So that's what they want us to do. So how do we do that? They want us to use an if statement. So they want us to use an if statement to do that. So um, if they are not the same, return an empty string, like I said. So we are assuming that per country, the text will be exactly the same, right? So note the comparison operator for strictly equal to in the Google Sheet is a single. So this is what they want us to do, to use to equate each of those columns rather than a double like we use in the pseudocode. Or we can use the EQ function, which is I feel like is a long journey. So what can we do if our incorrectly assume that the text were, so now this is what they want us to do. So to do that, they said we should use our if statement. So how do we use our, we've done our equal to, we click on if. So you can read from here, you can drop down to get more information about any formula if you are not sure. So what does if do? So if returns one value if our logical expression is true or false. So basically what it's saying is if we put in anything we put here, first of all, it has to be a logical expression. So it has to be something that would bring off a true or false answer. So right, so if the logical expression is true, it would bring out this value. It should work on this value. But if it is false, if this logical expression is false, it should work on this value. So that's what the if statement does. So now, from what we want to do, we want to confirm if these two are true, like these two countries, we've already sorted it in ascending order. So best believe you are sure that the countries of the same names are following each other, right? So if they are not following, then it's a different country. Then that country has been, I mean, that country name has exhausted. So what we want to do is we want to confirm if these two are same. So that will be our logical expression. And if they are the same, what will be our true value? What should it do? It should, if they are the same, what should it do? It should minus this from this one, right? But if they are not the same, what should it do? It should bring an empty string. So this one will be, if the value is false, it should bring out an empty string, right? So what will be our logical expression? So we've done our logical expression is going to be A3 is equal to A2. That's our logical expression. And then we will comma. And then if the value is true, what should it do? If the value is true, it should minus B3 minus B2. So it should minus this here from this one, right? If the value is true. But if the value is now false, what should you bring out? It should bring out an empty string. So this is an empty string, nothing is here, right? So, and then we close our brackets, we click enter. So we would fill this downwards. All right, so you can, so this is the formula. But some of the techniques we use most times is we try as much as possible to, I mean, we're not trying to assume, you know, even though Afghanistan is after Afghanistan, what if you had a situation whereby instead of Afghanistan, there's a space? Okay, let's say there's a space at the back here. It's Afghanistan with a space and Afghanistan without a space. They are not the same thing according to Excel, right? So we have to do something about that. So we have to do something about that. Or let's say we had, it was this one, this American Swana, and then maybe while the person was imputing the data, the person mistakenly kept double this thing and this one. So they are not the same thing. So we have to do something about that as well. Sorry. So how do we do that? How do we work, make sure to be 100% certain that our names, if Afghanistan is comparing Afghanistan, it is indeed Afghanistan, and not Afghanistan with an extra space, or Afghanistan with something, right? Or let's say if this one is in uppercase and then this one is in lowercase, they are not the same thing. It's not exactly the same. So we have to do something to make it exactly the same. And one of the things we do usually is that we trim it. So what does trim does? So trim would remove any extra space. So if there's extra space at the back here or in front here, maybe while they were writing it, the person mistakenly put space first before writing the Afghanistan. So it will trim those extra spaces off, right? Extra space in the front, extra space in the back. It will trim it off just so that's what trim will do. Now, we'd also use another function called, either we use lower or upper. What does lower do? So lower would, let's say, for example, we want to put is equals to lower, it converts our specified string to a lowercase. So let's say we want to use lower, and this is what we want to do. Everything will turn to lowercase. You can see that this is just Afghanistan, no more capital letter A. If you use upper, you see now everything is in uppercase. So what we are going to do is that we are going to feed our the information here in the if formula to make sure that these two are actually the same. So we would remove the extra spaces, and then would convert it to either upper or lower before we now check equals to both of them. We'll check the equals if A3 is equal to A2. So before we check if A3 is equal to A2, the computer would have done it inside, or the spreadsheet would have done it inside of itself, that okay, I'll trim on the extra space and then I would convert this to upper or lower. So let's use upper in this instance. So first thing we'll do trim. So we'll trim. So what does trim do? So trim removes leading and trailing and repeated space in a text. So we are trimming, but we also said we want to do upper. So would include upper. We want to upper, take everything to uppercase. So upper. So we're doing upper A3. So this is one bracket for the upper. So what it will first do, it will convert A3 to upper, right? And then we'll now trim the extra space. So we'll close the bracket for the trim as well. So that one is equal to, so take it to uppercase, trim the extra space. Now check if A3 is equal to A2. So now this A2 will do the same thing. Would trim first. So we'll trim first. Once we're done trimming, then we'll upper the same way we did for A3. And then we'll make sure we close our bracket just not to make mistakes. We'll close this one. We close for the upper. Now we are closing our bracket for the trim. So we close our bracket for the trim. So now it is doing what we want it to do. It would first take this to A3 to uppercase. Take A3 to uppercase and trim the extra space. Then it would also do the same thing for A2, and then it will equate both of them. Check if they are equal to each other. If they are equal to each other, it would minus B3 from B2. But if they are not equal to each other, it will bring out an empty space. So we click on OK, and then we'll drag it down. So now we are 100% sure that the names of the country are exactly the same. All right, so the next thing we'll do, we'll go back to our so it said use an if statement to only subtract 2 years to subtract 2 years if the country in the name is the same for the new feature ydiff, right? So if the country in the name column is the same, we should subtract the 2 years. So if they're not the same, we should return an empty string. So we are assuming that per country, the text will be exactly the same. So we've talked about this. So what can we expect to happen to our ydiff? So what can we expect to happen to our y diff if we incorrectly assume that the texts were exactly the same, if we didn't do this trim and upper? So if you had, I mean, if there was a typo, or there was an extra space, or there was a difference in capitalization, like I said, if this one is upper and this one is lower, even though they are both Afghanistan, this equal to would not be a true formula, would not be a true logical expression to bring out, I mean, to perform this arithmetic equation here. It will just go to bring out this, because it will see it as a first statement, and then it will bring an empty string. You might not see it in this first one, but you see it down the line in your work. So it's best to always be in the safe side, especially when you're comparing text. Make sure they are in the same unit, same case. All right, so they now so they did this flowchart and the pseudocode. The flowchart is straightforward. So we're starting. So to confirm if the name plus the name n plus 1 is equals to n, right? If it's a false, it will bring out empty string. If it's true, it would minus the n plus 1, year n plus 1 minus year n, and then to end. Same thing with the pseudocode, straightforward. So now it says, because we have set our if statement to return an empty string when the names are not the same. So we've told it to return an empty string if the names are not the same. So we can now assume that if we find 0 in our y if, we have a duplicate row. So find and remove the erroneous duplicate value from the data set and fix the broken y diff formula for the adjacent rows. So basically, what this is trying to say, let's go to our, it's saying that now that we've done this, we expect our value to be between, our values should be above 1. And why do we expect it to be above 1? Because we are minusing this one from this one, and we expect that these 2 years would be different years. So if we are saying 0, it means that we are minusing 2020 from 2020. That means, and if 2020 from 2020, it means the data set was collected in the same year, and that does not, follow what we've been doing since, right? Because what they said is that the two data sets were collected from 2 different years, right? That's what we've been able to assume so far. So if we're having 2020 year and 2020 year, it means there's a duplicate. So we need to investigate that and know what's actually wrong, right? So how do we do that? So there are multiple ways you could do it, but I like to, since, I mean, for me now, we've already confirmed from the get-go that Zimbabwe, it has 4 columns. So I'm believing that is it, because every other one has two columns. But what we'll first do is we'll just come here and then we'll create a filter just so we can confirm how many zeros we have. So for this one, it means that for one, it means that the data set they had was collected 1 year apart. But this one is meaning that the data was collected the same year. So that doesn't, align with what we're doing. So we just click on clear to clear the mark, and then we click on OK, just so we can see only now. So like I assumed, Zimbabwe is the one that is having 0. So we have to investigate it further to see what's actually wrong. Why is Zimbabwe giving us trouble? Right, so I would unfilter this one, and then let me just unhide this one as well. So I'll right click, I'll highlight first. Oof. And then I'll right click, and when I right click, I can unhide my column. So now I can see all the columns that I was hiding initially. So now you can see Zimbabwe more. If you look closely, you see Zimbabwe 2015, 2015. you look at the data, the POPEN, you can see that this is looking more like it was this particular data here, this one here, it was rounded up. You can see 32, 32, 13815, 13815, 13814. So it's looking like it was rounded up to the nearest whole number. But all this other data we are using, that we are seeing, you see that everything is, all the decimal points is showing. So since they are the same thing, this 2015, they told us to find and then we should remove. So we can come here and then we delete the row, right? Or another method we could do, but that particular one we won't be able to investigate for that. And rather we just investigate is that we come here, we go to data, we come to data cleanup, and then we remove duplicates. So since we are removing duplicate based off of name and year, so we'll just come here, and then we'll click name, we'll click here, and then we'll remove duplicates. So you see that 2 rows have been removed, like we've said. So, but the problem now is the row is removed were the normal ones. The ones that were rounded up. It didn't remove the ones that were rounded up. It removed the one that the actual value. So that's why I rather just investigate. So by investigating, I would remove this one. Instead, we should find and remove it. So I'll right click, I'll delete row. Then I'll come to this one as well. 2020 Zimbabwe. The numbers are literally the same thing. I would click here and then I'll delete that row. So now I have 463 rows. All right. So let me go back to, so now that we've found and then we've removed our erroneous data sets. So they're now asking us, why do we infer that y_diff equals to 0 equates to duplicates based off of our condition statement? I mean, based off of what we did here for y_diff, right? We said that if it's true, it should minus B3 from B2. This is B3, this is B2. So if they are the same years, it would bring out 0. 2020 minus 2020 is 0. And I mean, that's a duplicate row in our, if it's 2015, 2015 minus 2015 is 0. That's a duplicate in our own calculation because we already said that we have 2 different countries and they're having 2 different rows. So not the same. The records or the information was not gotten from the same year. It was gotten from different years. So that's the reason why we infer that it was a duplicate. All right. So now, what do they want us to do? They said they want us to create a newly summary sheet. So they call it summary sheet. So we'll create a summary sheet, and then we'll calculate the average year difference. So now we've calculated the year difference already. We'll now do the average of that year difference, and then we'll round it up to 2 decimal place. We round it rounded to 2 decimal place, and then we'll also calculate the minimum and maximum year difference in the same sheet. So let's go to our data. It told us to create a new sheet. We've created one sheet before, but to create sheets, we'll come here, add sheet. So let me just change the name. So to change name, you right click and then you type summary. So these are summary sheets. So what do they want us to do? Number 2, question 2. So they want us to calculate the average of our y_diff. So how do we calculate it? And then they want us to round it up into decimal place. So let's say average underscore y underscore diff. So that would be, average is the mean now. So click on average. What are we averaging? We're coming here we are averaging our y-diff because they want the average year difference. So we'll click here and then we'll click on enter. Where is this? Reference does not exist. Where's this error coming from? Okay, let's do it again. So is equals to average. Click here. Something is up. Let me try to let me do it again and see um average underscore y underscore diff. So is equals to average all right, let's do the mean first. Let's see. Max let me check the filter. So we have a ref here. Let me click on the ref and see. Mm,
It's not a mistake. You just drag down the 5 again because you remove the duplicate.
yeah, that was what I mean. I could see it here from the formula. Is indicating that it's calculated with from an empty sheet. So okay, Control Z. Let me just computer. Okay, so you come here and then you drag it down. Thank you for that. All right, so once we've done that, we already have our average and then we have our max. Now, they told us to round up to 2 decimal. So to round, would round. Now, this is the formula for round. It says round a number to a certain number of decimal place according to standard rule. So the place, this is in place means like in 2 decimal place, in 3 decimal place, and they already told us in 0 decimal place, they already told us that we should round up in 2 decimal place. So round, we come here, put comma, and then 2 because we want to round up in 2 decimal place. Then we click on enter. So rounding up in 2 decimal place will give us 4.8. For our maximum is 5, and then our mean, see the same formula. I mean, we're still referencing the same column from a different sheet, the estimate sheet. So all we just have to do, we just copy this one and paste it here, and then we'll change this to mean because it's mean we want to do. All right, so from what we can see, we can see that the maximum is 5. The maximum year difference is 5. It means that from the first year and the second year, we have about 5 years interval. And then the average is also 4.8, which is closer to 5. So it means that most, like we've already been seeing, most of our data, right? Most of the data were collected in 2015 and 2020, which is, 5 years interval. And then the minimum is the one that was collected within 1 year. Maybe they collected 2015 and 2016 or 2018 and 2019. So now that we've done that, we've rounded up, we've done the maximum difference, we've done this. What do they want us to do next? So they want us to, so they're asking us, how does the average year compare to minimum and maximum? So we've already answered that. I mean, we can easily tell that the data set itself is not widely spread. It's basically within a certain year, which is 5 years. And that's what the average is telling us. And the maximum is telling us. So we have little outliers like we've been seeing, which is the ones that are 1 year, 2 years, but very few. So the next thing they want us to do is they want us to create a histogram of the year column. Note the minimum and maximum value on the horizontal axis. So they want us to create an histogram for the year column. So this is the year column here. So we'll click on this and then we click on insert and then on the menu bar and then we click on chart. So we come here to change our chart type. What we want is an histogram. It's a histogram. So we'll click on histogram. Right. So now that we've clicked on histogram, we would have to. So now that we've clicked on histogram, they told us that we should represent our minimum and maximum, right? So to do that on our horizontal, this is our horizontal, our x-axis. So to do that, we'll come here, we'll customize, we'll go to our horizontal axis, and then we'll represent our minimum. So minimum meaning minimum, since we're doing year, means minimum year. So minimum year means 2015. Just for more clarity, if you come here, you click on filter, that's on our year column. Or wait though, I've done something like that. Yeah, this is minimum year. When we did the year, minimum year, and then the maximum year. So our minimum being 2015 and our maximum being 2021, 20, sorry. So we'll go back to our so we'll edit our chart, our histogram chart. So click on these 3 dots here, click on edit the chart, come to customize horizontal. So they want us to put minimum and our maximum. So the reason why we're putting minimum is so that, like, as you can see now, the way the chart is coming, it's showing years that we don't need. We don't have 2095 here in our year. It was from 2020, 2000 to 2020. So seeing 2095, not needed. Seeing 2023, not needed. So now, if we input our minimum value, it would create our graph in such a way that it will start from a particular number and then ends in a particular number. And now that we've known that our minimum is 2015 and then our maximum is 2020, so we are doing histogram. So I would have said we should put 2015 and then 2020. But because it's an histogram and the way histogram operates, it takes in value within a certain range, right? So meaning, let's say you have a set of value now, you have 1, 2, 3, 4, 5, 6, 7 to, let's say, 50. If you want to do an histogram will take 1 to 4 together, 2 to this together, like that, like that, like that. So because of that, I would reduce this and I will increase this just so it can accommodate any other one that, I mean, it can show the true picture of the data. So I'll change this to 2014 and then this to 2021. So now we can see our data clearly. And one more thing we would have to do, we would have to come to this histogram and then this bucket size. So if we are familiar with histogram very well, we don't have any space in between here. We usually don't have space in between here. We don't have spaces in between here. So we have to do that, and to work on that, we'd have to deal with our bucket size. So bucket size is that space, so we'll change it to 1. So now that we've changed it to 1, so it's clearer now. So this looks more like our histogram. So our histogram being histogram of the year. So from what we can see now, we can see that I over this, we can see that 231 countries had their year within 2015, and then 213 countries, same thing as the column stats we did initially, right? So the histogram has showed us that, I mean, they are not evenly distributed. Evenly distributed will be giving us like a bell curve shape, like progressing as a peak and then it comes down. So, or from what we can see in this histogram, we can tell that our year column has 2 different peaks, which is within 2015 and then 2020. So we'll click here, we'll move the sheet, we'll move it here. So we've done our histogram. So what can we say about our distribution of years? So like we said, it has 2 peaks. It's not the bell curve, it's not skewed to the right or skewed to the left. It has 2 peaks. So now the next thing we want to do, is investigate the annual rate of change. So what is our annual rate of change? Right, so we're investigating our annual rate of change for nation, for rural, for urban, and this is a new term, they're just introducing it. But if you check online, you will be able to tell what an annual rate. So an annual rate of change basically just tells us that on average, how much access to drinking water has changed per year. So it means in that 2015 that we were seeing, or in this 2015 that we are seeing here, 2015 that we are seeing here for United States, and then 2020, what is the difference? Has there been any change? So that's what the annual rate of change basically tells us. So we are going to calculate the annual rate of change for national. We'll compare with for national in the national level, this watts base n in their national level. What is the change? Has it improved? Has it declined? Are they doing better, right, from 2015 to 2020? We'll calculate for rural too, and then we'll calculate for urban. So that's what they want us to do. So now the next question they want us to answer is, what is the average of the different ARC? So once we've calculated all this for national, rural, and urban, they still want us to calculate the average. They still want us to calculate the average. All right, so We want to see if the access to service is improving or declining across national, urban, and then rural areas. The United Nations uses the annual rate of change to see whether the proportion of access to drinking water is declining or improving. So they've explained what the annual rate of change does. It shows whether the proportion of access to drinking water is declining or improving. So now, it's saying United Nations uses the annual range to see whether the proportion of access to drinking water is declining or increasing. The annual rate of change is a statistical measure used to express the average yearly change rate of a variable over a certain period of time. So it's a statistical measure used to check the average yearly change rate of a variable over a certain period of time. So how is it calculated? So this is the calculation here. This is the calculation here. So basically, annual rate of change of the nation, let's say we're doing nation, is equal to the water assets in percentage. So this is the percentage of the water assets in nation of the first year, and then you are minusing it with the assets, the percentage assets, water assets of that same nation in the second year, right? And then you do divide it by the difference, which is what we've calculated before, the y diff. So they're now saying in our Google Sheet, we need to do a row calculation between 2 years of the same country to calculate the annual rate of change based on our column names. So our ARC equation, this is the equation they want us to use. It's still the same thing with this, but they are just being more specific. So the ARC for X could be nation, could be rural, could be urban. What base? X again, nation, rural, but the year before, the previous year minus the current year divided by the year difference, which we've done before. Okay, so and they are just reminding us that what base X values are already in percentage, because this thing is supposed to give us annual rate of changes in percentage as well. So we don't have to convert to percentage. We don't have to times by 100 or whatnot, because it's already in percentage. So, and we did something similar to this in our previous chart. So now this is showing us how to calculate our annual rate of change. So how do we calculate our annual rate of change? They want us to create 2 new rows. So these are the 2 new rows, the 3 new rows, sorry, they want us to calculate. Let me control it in our data set. So these columns represent the annual rate of change for the country's national, rural, urban population. So calculate the ARC for each of the new features when the two country names are the same. So if the two country names are the same, they want us to calculate the annual rate of change, like we said earlier on. As with calculating the y diff, we only want to calculate the ARC between the 2 years when it's the same country. In other words, we will only calculate ARC if the country name is the same for the 2 years. Now, considering that we have the same condition on year and names for ARC, N, ARC, R, and ARC as y diff, what would the flowchart or look like, and how would we change the, so we're not doing flowchart here. So this is what they want us to calculate. So we'll do that. Let's go to our spreadsheet. To calculate, since we are using the watts base, just so we can see everything clearly, we'll remove all the things we're not needing. Okay, let me don't do that. Let me just go. Okay. Control V. Control X. So ARCN. Control X. ARCR. And then ARCU. So let me bolden this. So, like the formula already stated, what are we doing? So, still, we are going to confirm. We're still making use of what we used here, right? This first equation. We are going to confirm. This is what they want us to do. We are going to confirm if these two countries are the same thing. If these two countries are the same, then we'll now do the formula. Instead of minusing this one from this one, it will be the formula that will be here. But if they're not the same, it will bring out an empty sheet. So the formula being we're minusing this one from this one, and then we are dividing it. Okay, the formula being, let me go back to the formula. Yeah, so the formula being this one minus this one, and we're dividing it by the years. We're dividing it by the years. Now, you can see that it said watts base. So, meaning that if we're doing, I think I have to, let me just add it so that you'll be able to see it all. Hide. Hide. So I'm hiding all the data as we are not using. What you could see that what they want us to use is from the formula. They specifically wrote watt base. So we're not making use of the watt lim or the watt unimproved or the watt SUR. So it's just watt base. So I'm hiding all the ones that are not watt base so that we will be able to see. So we'll be able to see it clearly. So now we have watt base N here, watt base R here, and watt base U. Yeah, so we have all the watt base N, R, and U. So what they want us to do in this ARC N now, what they want us to do is, first of all, we'll check if these two names, these countries, if the names are the same thing. If they are the same thing, what are we going to do? If the names are the same, would, rather than minusing the years, would, for our numerator, would minus this from this, and then we'll divide with our year diff. So what is our year diff? Our year diff is this minus this, but we've done it already. Again, so we're minusing this second year. So the base, because we want to know if it has improved over a certain year. So we want to know if this water basic access has improved. For example, now you can see that in 2020 we're having 75, and in 2015 we're having 16. So logically you can tell that it has improved, but we want to know it in percentage, like how much of an improvement over that extended period of time, over the 5 years, how much of an improvement has it improved. So that's the reason why we're doing this ARC. So like I said, we'll still be making use of that trim. If they want us to check these two things, we have to make use of this one. So let me just copy this formula from here, and then we'll continue from there. So we'll Control C there, and then we'll Control V here. But we need to edit this formula, because in this formula it's just basically saying if these two are equal to each other, right, it should minus. But that is not what we want to do. We want to minus though, but we're minusing these two instead from each other, and then we are dividing by this one here. So how do we minus? So we'll just come here, we'll change our formula. So which we're minusing from E3, because it's watt base N we're doing. So we're minus from E3. So E3 minus E2. So we change this to E3, we change this to E2. So now that we've minused it from each other, we have to put it in brackets before we divide so we don't cause problem. So we bracket it because they want us to minus first, and then we divide, by our year diff, which is our Q2, right? And then we divide by our year diff, which is our Q2. So let me just cross check again. So what it's first doing is to first check if A3 is equal to A2. If A3 is equal to A2, then to do this formula. The formula is minus this one, right? Once you are done minusing, then you divide by A2. So, and then we click enter. So okay, let's go on to fill yet. So we click enter. All right, let's autofill. So once we do that, we can go to the side. So since it's the same formula, right? It's just difference in words. So we'll just come here again. We'll feed it to which is a new system and it's stressing me out. Control Z. So I'll just put it here. All right. And then so it's the same formula. So why are we not having any figure here? Why are we not having any figure there? So we need to change. Now that we've dragged it to this place, you would see that all these things are changing. For example, this is A3 here, A2, right? In this end, this is E3, this is E2. I think that they spoke about something there. Let me just go and read what they said before I continue. So he said, calculate the ARC per country. Only calculate the ARC between 2 years of the same country name, which we've done here, right? And then he said, create 3 new columns. So they want us to create for ARCN, ARC, we've done that. We've created those new columns. So they said we should calculate the ARC for each of these new features when the 2 country names are the same. As with calculating YDIF, we only want to calculate the ARC between 2 years when it's the same country. Too much talk. So considering that we have the same condition on year, name for ARCN, ARCR, ARCU, okay, we've seen this. So since we are calculating the same value based on different column, we can use both absolute and relative reference in the formula to ensure that the correct features are being used for the condition we are calculating. So this is what I was trying to explain. So again, this formula, they are the same thing, right? The only thing that will be changing, because we're using the same. First of all, what are the same similar things in this formula? If you look at what this formula says here, it says what's base and the year before minus the current, the current year minus the year before, right? Or the year, the first year minus the second year divided by the year difference. So you would see, and this is specific. If it's nation, it will be nation. If it is rural, it will be rural. If it's urban, it will be urban. That's specific. But that's specific. So urban will be urban, rural will be rural. But this here is not specific because whatever, either it is urban, rural, or nation, we are still using the same number of years. It's still the same year difference we are using. And then we're still using the same countries. We're still checking if those 2 countries, let me go back here. So for better contrast, to calculate this, we're using this minus this divided by this. All right. To calculate this, we're also using, rather than using this one, we're using this, which is the what base R, the first year minus the second year divided by this same year difference. So you see that year difference is constant. Even if we're using for urban too, it's still the same thing. We're minusing this what base U minus what's this one here, and then we're dividing it by the y diff. So you see that it is constant. So this should actually be, it should actually hold a mixture of absolute and relative. And also this one too, before they can do any calculation, the first thing they will first do is look at this name to check if they are equal, right? Whether they are doing arc n, arc r, we have to always check. So also we need to do a relative this thing here. So how can we make it that when we move to the side, this would not, this one here would not change from what we want it to change to, and this one here, because these two are actually, they should be the same across board. This equation here equating these names together, and then this year difference, they should be the same across board. So how can we do that? You know, that's where the relative comes in, relative and absolute, right? So to make something absolute, we put a dollar sign in front of it in Excel. So if you can, now to make something absolute, you can either make the column, that's column A, absolute. If you want to make column A absolute, you put dollar in front of column A. Or we can make column, we can make row 3 absolute. If you want to make row 3 absolute, we'll put dollar sign in front of row 3, right? So it being absolute means whatever, anytime we probably move the formula to this side, it would not change. So look at this, for example. Now this is A3. If you come here now, you see that it's no longer A3, it has moved to B3, right? If you come here now, you see that it's no longer, it has moved to C3. So every time, because you are moving it, all this alphabet and numbers are, all this alphabet, because you are moving to the side, you are moving to the side, like this, alphabet are moving. If you are moving downwards, numbers are moving. So you have to absolute it. If you absolute it, it won't change. For example, now let me put absolute here. Let me put the dollar sign here. Okay, if I move it to the side now, you see that it's no, it didn't move from A to B, it's still on A. You see this one is still on A. So that's the beauty of absolute and relative. So now we need a mixture of absolute and relative for this one and this one here. So how can we figure that out? How can we know what we are, how we are absoluting it and how we are going to do it? So let me just, so just by looking at our this thing, we know that this column A has to be constant. We don't want it moving from column A. That's for our equal to here. We don't want it moving from column A to column B, but we want it moving from 2 to 3 to 4. So if he has checked this 2, it should come down. He has checked this 2, it should come down. He has checked this 2, it should come down. It should not move to this place. Even if we move it, we take it to another side. So we need to absolute our column A because we don't want our column A to move, right? We absolute our column A, but we'll leave our row numbers alone because we want it to move. Once you are done with this to come down, once you are done with this to come down, once you are done with this to come down. So we'll leave it. We'll do the same for this one too because these two are working together, right? So we'll absolute our A, our A's. Now, another thing we need to absolute our column A, another thing we need to absolute is this one here, is our Y diff, right? We also want it to come down. We don't want it to move sideways. So we have to absolute this one as well, right? So how do we absolute? We've already set out to absolute. We'll put dollar sign in front of it. So we'll put dollar sign in front of this because we want this one to stay. And dollar sign here too because we want this one to stay as well. And then we'll also put dollar sign here because we want it, this column to stay. It should just be coming down. It should not move sideways. And then we click enter. So now that we've done that, since we've absoluted all the ones we should absolute, we'll just come down. So we'll fill it up. So once we are done filling it up, and then we'll move it to the side, because you see that now there are numbers. Initially, when we did it, there was no number because we had not absoluted it. But now that we've done that, we just have to like double check this one is correct because we did it ourselves. We have to double check here, R and U, to see if truly what we said it should do, that was what it did. So we come here and we say, okay, it's still on A3 minus, A3 is equals to A2, good. Sorry. A3 is equals to A2, good. And it's still using our Q2, which is our Y diff. So that is also good. But we are looking at F3. Is what base R we are using, and what base R is not F, it is I, right? So we need to change it because what we have for ARC rural, it has to be what base R that we're working with. For ARC urban, it has to be what base U that we're working with. For ARC national, like we did, we work with what base N, right? So we have to change it. So we'll change this minus here to I instead of F. We change it to I. And the reason why it's giving us F is because we moved from this E to the next place. And if you can remember vividly, you will notice that we had F, we had before what base R, we had what base N, what base limb N sub N, like that. So, but we eat the, let me just unhide this so that you can see what I'm saying. So you can see them. This is all the things that are here, right? So we can't use this. So let me hide it back. All right, so hiding it back. So this is what we want to use. So we'll change it to I. So this will be changed to I. This one will be changed to I. Because what we want it to do is that it should minus this from this, right? Before you now divide from this. So click on OK. Once we've done that, we'll just drag downwards. All right. So we've done that. So we'll do the same for this one. What base U? ARCU. So it has to be M, column M, not G that we are seeing here. So we change this to M. And then we click enter. So once we've done that, we'll drag it down just so the formula can fill the rest of the cells. All right. So we've done what they want us to do. Let's move forward. So moving forward, what do they want us to do now? They said we should calculate our ARC per country. Only calculate the ARC. We've done this. Calculate the tree, namely, we've done this. So since we are calculating the same value based on different column, we should use absolute and relative reference. We've done that as well. So we've used the absolute and relative reference. Another pseudocode. So this is more like just trying to show us why we should and why we should not use the absolute. So we've done that. I think there was somewhere they said we should do average, or am I missing it up? Okay. All right, so what are we to do now? So they said, why do we observe the value error in all three columns? And how can we change our formula to ensure that we don't observe this error? First of all, So when we go to our this thing, we see value error. Without even looking too far, you can see no, no, no. Everything we are doing our arithmetic is numbers. You can't minus or divide or subtract a number with a text. Null is a text, right? Null is not zero. It's a text. It's a categorical data. It's a string data. Yeah, it's categorical data. So we can't work with it. So we have to fix this null. So this is the reason why we are getting this value error, because it's not a number. Function minus parameter expects number values, but null is a text and cannot be coerced to number. So we cannot turn the null to number. And that's the reason why, especially cannot turn the null to number. That's the reason why we're getting this value error. So how do we fix it? How do we fix it? Right? So to fix it, they are saying we see that the error is observed in rows where one or both of the word base, whatever, as null, like we rightly stated. So we need to add the if error function. So we need to add the if error function to the if statement in the future ARCN, so that the output ARC value is an error. Okay, so that if the output of ARC whatever gives an error value, we should replace that error. Instead of seeing that error, we should replace it with a null value. Right, so that's what they want us to do. So would we observe in our data set if we treated, so they're asking us now if instead of the null, if it was missing, if it was a blank value, are we going to see if it was an empty value without text, are we going to see the error? No, we won't see error, because blank cells, simply the computer will look at it, or spreadsheet will see it as 0, right? So it will just calculate and it won't give us, any issue. So now we need to fix this with an if error statement. So how do we fix our if error? So what does if error does really? So if error basically looks at so what does if error does? So if error, let me just go to our spreadsheet. It said we should use an if error. So first one here, we should use an if error. What does if error does? You don't have to cram anything. You see everything you need here. So what does if error do? It returns the first argument if it is not an error. Otherwise, it returns the second argument if error is present. So what it's trying to say is that for if error, you have two arguments, right? Right? You have two arguments, the first argument and then the second argument. So if whatever it is doing, if it's an error, the first argument would not come up. Sorry, if it is not an error, like if it is good, the first argument would be the one to come out. But if it is an error, the second value, or what the value we put here, not argument, sorry, the second value we put is what it will come up. Just to repeat again. So for example, if we say 0 divided by 0, if 0 divided by 0, obviously anything divided by 0 should give us an error, right? Because it's 0 divided by 0, if you put if error, if you put something here that, okay, if it is error, it should write something else here, is that something else that will come out? It will not bring out a 0 error, right? So that's what this is basically just telling us. So we'll put an if error. So meaning if this we're putting an if error in front of this our whole equation. So meaning if this our equation, if it is not an error, it will run this. But if it is an error, it will run the second thing we want to put here, which they told us to put null. They told us to put null, right? So we'll put null. So again, what it will do is, if it is an error, you see that I'm on null, you see that it is highlighting it. If it is an error, it will write, instead of putting error, the value error, it will put null there. If it is not an error, it will run this calculation. So let's enter. So I've entered. So let me just take it down. Okay, just by looking at it, you can see that we have null here. We've removed the if error value, the value error. So we'll do the same thing here too, just so we can remove all of our value error. How are we doing? If error, and then we'll come here, the second value, comma, which is a null. We'll put null here, put enter, do it for here too, so that we don't have to repeat. If error, comma here, null, click on enter. So drag it down just so we can remove all the if errors. That we go up again. So we'll do the same thing here. So now we've been able to remove all of the errors. So just to confirm, let's just filter. Let's filter to see if we still have any if error value. You see, no more if error. But we have none because we've converted the if error to none. Let's do for the second one too. No more if error is null we have. So we can unfilter. So now we've been able to clear the error. So what does it want us to do? And then we've also identified that if it was a blank that we have here, rather than null, it would not give us error because it sees blank as it can perform arithmetic formula with blank. So what does it want us to do next? So the B, they want us to calculate the average, minimum, maximum for each of the ARC values for access to basic service level for each of the three population group. So population group being okay, so in the summary sheets, calculate the average, minimum, maximum of ARC. That's the annual rate change for the nation, annual rate change for the rural community, and then annual rate change for the urban. So that's what we're doing. So we'll calculate the average. So we should, in our summary, this is the third thing they want us to do. So in our summary, so we have to calculate average underscore ARC underscore N underscore ARC Bazen. Let me just do Bazen. Baz underscore N. So this is for N. So we are calculating the mean as well. Let me just do it this way. Change this to mean. Change this to max. So we're doing it for R as well. R. So we're doing the average annual rate change for basic water access in the rural. We're also doing the minimum, and then we're doing the maximum. Also, we're doing the same thing for urban. You know, they told us to do this for national, rural, and urban. So I'm writing it down. So I'll change this to minimum. And I'm changing this to maximum. All right, so now let's calculate our average. So how do we calculate the average? It's the same thing. So we just do is equals to average, click on average, come to the sheet where we want to ARCN. So this is the column we're working on. Click on enter. Right. So now that we've done that, we'll just drag it down. So dragging it down, reason is still, if you notice, it's picked from column R. It's still column R that is in. If you come to maximum too, it's still in column R, and that's the reason why the distance are the same thing. So all we just need to do is change from average to minimum. And then we'll change from average here to maximum. So yeah, so we'll do the same thing for this one as well. So we'll do the same thing for this one here. Is equals to average. Come here, rural. So we'll click on OK. And then we'll drag it down the same way we did it, just because we are dealing with the same column, rural, all of them. But we'll just change this to minimum because we want to find the minimum value here. And then here we want to find the maximum value, so we'll change it to maximum. We'll change to maximum. All right, so the next one here, it's equal to average what base U. So we'll come to this, we're using the ARCU. So we'll come to this column here, click on enter, we'll drag it down, and then we'll change to minimum here. Because it's minimum once calculator, and then we'll change to maximum here. All right, so we've been able to do that. Let's continue. So it says, because we divided by the difference in year, the ARC indicates yearly change in access in percentage points. Yes, we've been saying that since yes, it is percentage, because everything we're dealing with are in percentage. All these things here. Initially, when we were trying to understand our data, we said that what base n is in the unit is percentage, base r percentage. So yeah, you expect this to be in percentage. So basically what this is reading is percentage. All right, so let's continue. It's percentage points per year. Just for more clarity, right? This minimum, you see that you are saying between negative and positive, right? This ARC, if the ARC of a particular place, if it falls, if it's minus, it means there's a decline in progress. If it is positive, it means there's an improvement. If it is zero, it means there's no improvement at all. It's the same thing, no change. No, not there's no improvement, but no change. Meaning that the way it was in, let's say, for example, now, let's take this Andorra, for example. It means that this 2020 and 2015, there has been no, see for rural, you can see 0, 100, 100. There has been no major change. There's no change because Andorra already had 100 before. They had good access to basic water normally in their country, even they are rural and they are urban. They have good access already. So from 2015 to 2020, there's no change. So that's the reason why we're getting 0. But if you see this one now that is minus, this one that is this ARC that is minus, it means there was a decline. So you can see in 2015 they had 99.97. In 2020 they had 99.96. So there was a very slight decline, but it's still a decline. Let me see if I can see any country that has maybe like a major decline. For example, this one now, it's not that major, but it's marginal. So for example, now see this ARCR, that's Burkina Faso. So in 2015, Africa, in 2015, right, their basic access in their rural community was 38%. But in 2020, it reduced to 32%. So there's a decline. That's the reason why you're having a negative value here. So like the ARC does, it checks the annual rate change, right? So that's what it is telling us. So we can rightfully see all of this here. We have minimum, we have negative values, meaning we have values that showed a decline. We have positive values, values that showed improvement, and that's the reason why we're checking for minimum and maximum. We're not just checking for no checking sake. The average as well, just to tell us most of the data or there was actually a slight improvement. Most of the data was slight improvement between those 2 years. So that's what this average is telling us. So it says that we observe that the rural ARC value is higher than that of the urban national population. What does this tell you about the rural versus urban and national access? So we observe that the rural ARC value is higher than that of the urban and so let's see the rural. So this is the rural, the average of the rural is 0.48. The 0.48 is actually more than 0.527 for national and 0.15 for urban. So we can easily see that rural is higher. But does that really paint the true picture? Does that mean that people in the rural community are having more development than the urban and the nation? So we need to still do further investigation to understand. So let's see. So it said it's easy to jump to conclusion that okay, since the average from our calculation is higher, it increased more significantly per year than the urban assets because the ARC value for the rural is higher. So however, we cannot consider this, and the reason why we cannot consider this is because of this reason here. Observations where assets are already 100%. Actually, there are two reasons. Observations where assets are already 100%, and then observations where there was no improvement. The numbers remain the same. So to put more perspective to that, let's go back to our chart. And we go to for example, now I showed you one country, I think it was Andorra, right? So for Andorra now, he has 100. They had already maxed out their improvements. They can't improve more than that because everybody has good water, right? So in 2015 they had good water, in 2020 they had good water access. So it has maxed out. So doing this is zero, is showing us no change. And if you do the average of zero, is like putting zero in an equation, is literally not doing anything. Do you get? Because it's not impacting the data. But that does not mean that there was no, what's it called? I mean, there was a decline or whatever, because they had already maxed out. Now, another example would be countries where they have exact, for example, now this one now, it's not 100, right? But it still give us zero. Because in 2015, they had the same number with their 2020 Bermuda, 99.9, still at 99.9. There was no change. So it will still give us zero, right? So all these zeros are affecting our result. And the places where you see all those zeros the most would be in national and urban. Reason being because there's really no much change that could happen. They've maxed out their changes. But rural is a rural community. So whatever the case might be, there's still going to be improvements. Major rurals. Though there are some countries that their rural self is urban for some other countries, but majorly rural should have this thing. So that's what is affecting or skewing our data. So we need to do further investigation. So when access to basic water service per country is reported as 100% for both countries, the ARC values are equal to 0. And if we calculate the ARC values over all countries, right? Because now we're not dealing with one, we're calculating over 100. That 0 is not making any difference. Is a relatively large portion of those equals to 0, our average will become lower. So it will affect our average because we're having 0. It's not doing anything. So in other words, a lower ARC value as calculated before does not necessarily indicate that less progress is changing. Does not mean that there's less progress in changing. Does not mean that urban are falling behind because they're having lower, or does not mean that national because they're having lower. No, it simply means that they've maxed out major, or there was not change per se. So in other words, does not mean that it necessarily indicates less progress in changing access to basic water service because it takes into account countries that already have an 100%. So considering what you already know, considering that our water access future hasn't been rounded, how can we determine the numbers of countries that have full access to basic water? To check a country that has, is still filter. Once we filter out, we can easily see countries that have, you know. So let's see. They ask for anyone, okay, basic, that has full access to basic water supply. So let me just basic access. So filter. So we'll do country 100. Just look for the one that has 100%. So you can see this is 100. These are countries that have 100%. But you can see like what we had initially in that previous part 1, we're having 100.00003. So this is not the same thing as 100%. And the reason why 100%, the highest percentage can go is 100. Am I mathematically right? Well, so 100% should be 100% if you are referring to one item, right? So this 37, 0.00037, we're getting this because maybe while they were imputing or gathering the information, point this thing here, point that thing here, adding all those things now made them have this extra 0.0003. So this can still be regarded as 100%. So to see countries that have 100%, we can easily just, filter out only the 100 and then show it. But we ain't doing that. But yes, that's how you do that. So let's go keep reading. So now we've done our investigation by ARC, right? Investigation by ARC, that's the annual rate of change. Now we want to investigate by access by area. So how are we investigating? So what does the change in the access to basic water look like for different areas? How does the ARC differ between rural and urban population? So in our previous investigation by access by area, we observed that the rural population on average has lower access to basic water. This now they are referring to our investigation project part 1. So because in that one we noticed that rural population on average, they have lower access to basic water than national or urban. Now we want to investigate whether the countries have made significant enough effort to improve this in the years. So we want to see how much improvement have they done, because what the data we dealt with in part 1 was I think 2020 data. So now we want to be, now that we are saying between 2020 to 2025, we want to be 100% sure that yes, was there an improvement, was there a decrease from that 2020 to 2000 to 2020. So we come down. So what does it say we should do? It said we should calculate the number of countries per area that have full access, and then the annual rate of change equal to 0, and then smaller than 0, and then greater than 0. So what do they want us to do? So they want us to the numbers of countries per area, right? So they want us to countries that have full access, meaning 100%. They want us to have that. Then they also want us to have countries that their ARC is equal to 0, right? So to get the distinction, full access will mean 100%. ARC rate equal to 0 could mean 100%, could mean 99.9 in the 2 years, could mean, let's say the first year had 15% and then the second year had 15%. The ARC will give us 0 because there was no change. The same in 2 different years, they had the same percentage. So this is a different section, and then they want us to do the one that is smaller than 0, people that declined. So we want to know the numbers of countries that declined, that ARC declined than 0, and then we want to know the numbers of countries that their ARC was greater than 0, that improved, right? So in summary, they want us to calculate the numbers of countries that have the missing ARC values, the numbers of null occurrence in each of those columns, ARCN, ARCR, and ARCU. So what we want to do, so this is 5 things now: full access, 100%, ARC equals to 0, 1 thing, smaller than 0, greater than 0, another thing. And then they now want us to find the ones that we don't have values for, that we wrote null occurrences, that we don't have value for. So what are we going to do? So in our summary sheet, also calculate the numbers of countries that have full access across both years, i.e. the numbers of countries where access is 100% for both years reported. The numbers of countries where access is 100% for both years reported. So as in previous part of the project, we have access to basic water entry that are greater than 100, which is not possible, right? So they want us to create a new column in our original data set saying Watts base N rounded, Watts base R rounded, and then Watt base U 100. So what should we do there? So what are we doing there? That are the original access to basic water column, right? And then rounding up to 0 decimal place. Now take note, 0 decimal place, it means we are rounding up completely. So what this is doing now is basically anything that is like 99.6 becomes 100. Anything that is like, for example, that 100.0000035, it becomes 100 as well. Right? So they're now saying now, since that now that we are no longer using 100%, that if you round it up, all this 99.6 becomes 100. What does that mean? So it means that it's not full access anymore. It's an approximately full access, better still. So what we need to do is to create that. So let's go back to our data sheet. So Watt base N rounded, Control X. Another one, Watt base R rounded, Control X. All right, so we are rounding up to decimal place. We are rounding up to 0 decimal place. It's still the same rounding up formula. We don't have to do much. But mind you, when you're rounding up, take note of the null. Null has been giving us issues since, and that's because we are waiting for them to tell us we should put our if error. Right about now, we should already know that when we are working, we have to put our if error, because this null is not going anywhere. The nulls here are not going anywhere. So we have to factor it into whatever we're doing before we even do it. So they want us to round Watt base N to 0 decimal point. We don't want to be seeing 61.33. We want to just see 61. We don't want to be C75.0, we want to see 75. This one is 99.77. We don't want to see 99.7. Take it to 100%. So that's what they want us to do. So the same thing we'll do now that we're considering if error. So let's just first even do the round first. Is equals to round. So what does round do? So it rounds up a number to a certain number of decimal place according to. So this is where we'll put the place. We've done this before. So what base n, we click on what base n. How many decimal places are we rounding up? 0. We don't want any decimal place. And then we'll cover. We click OK. We're not auto-filling yet. We need to factor in our if error. So just because it would still work, we have to factor in if error because of our null values. So it's still the same if error formula. This is the value you should bring. But if you run this and then you have an error, let's say there's a null and you cannot do rounding with null, instead of bringing an if error, just jeje print null. So that's what that means, right? So we'll do it for this one as well. Let me drag downwards first. All right. So let's do for this one as well. Okay, let's just copy the let's copy the formula. Control C, copy the formula. We paste it here. We paste it here. The reason why we're copying the formula is because it's the same thing we're doing, right? But we'll be changing, rather than you referencing E2, which is the rather than it referencing E2, which is the what base n, we want you to reference R column I, which is the what base R. So we'll change this in the formula to I2. See, the number has changed. So this one too, rather than referencing E2, because we copied, rather than referencing, we want you to reference M2. Right, so we've done that. So we drag downwards. All right, we go up here again. We do the same. All right, so we've filled in everything. We've done all the, we've rounded it up. So let's go back to what they want us to do. So now that we've rounded it up, this is still what they want us to do here. Well, we'll talk about more about it downwards. So they want us to create. So they want us to create a new column called ARN full. We're creating ARN full. And what would ARN full do? In this original data set, that it's an original data set that determines if the country names are the same and that both what base n rounded feature for that country are greater than 99%, and then to return full access. So now we're doing our full access. So basically what it's going to do is that it's going to check, what the what n full is doing is going to be a formula, a logical formula whereby it will check the two countries like it has been doing since. If they are the same, fine. What will it do? And if the rounded figures are the same, so it will give us full access. That's one thing he wants to do. Now, so we already used an if formula, if statement to determine whether the cell we are referring to are the same in our previous. So let's move past. So once we've done for ARCN full, we are going to create two new column as well. Would get for ARCR full and ARCU full using the same calculation. So we want to see now which countries have same name and then 100%, 100%. If they have those two, we should return full access. It means they have full access to basic water supply, right? So they are good. They don't need to be in the data next time. They are clear. So they want us to find that. So now set D. In the summary sheet, calculate the number. So once we have done this in the original data sheet, we'll go to our summary sheet. We'll calculate the number of countries that have full access, meaning they are already settled, they don't have issue with water anymore. So, and then number of full access occurrence in each of the newly created. So we'll do that. So let's go back to our data set and then work on our full access. So to calculate our full access, what formula are we using? They've told us. So initially, when we're checking our full access, our whatever, we're making use of watt base n, watt base r, watt base u. That's what we're using. But now, because we've rounded it up, so they want us to make use of this. So it's taking into consideration the ones that were 99.9 that we've rounded up to 100. So now we want to know the full access. So how are we going to do that? So let me go back to pick. Okay. Control C. To the right, just gonna create more columns. It's not like Excel that has infinity. You have to keep on creating once it gets to Z. So put this one here. So now we have ARCN full. So this one that is for people that they are ARC, I mean, they have full access already, 100% in the national level. This one are the people that have full access 100% in the rural level. This one are the people that have full access 100% in the urban level. So how do we calculate? So we are using AND formula now. And the reason why we're using AND is because if you come here, you can see they even highlighted the AND, right? It's no longer a situation of, because previously what we're doing, this for example, so it is checking if this one is equals to this one and then it's calculating. But now it's not just that, it's checking what is checking. What this ARN full is doing is that it would first come here. It will come here, check if these are equal to each other, right? Once it's done checking, it will now come here again. Let's say we are doing for n, ARC n. It will now come here again and check these two if they are equal to each other. So you see there are two logical expressions, and to join two logical expressions, you can either use and or, right? And then this one is a must that the two must be. So it must be same country, and then the national basic or national basic access to water rounded, or national basic access to rural basic access to water rounded, or rural urban basic access to water 100 must be equal to 100, right? So there are two different things. The name of the countries must be the same, and then the access to water must be 100% for both of them, for both years. So now we will be using the AND formula. So what does AND do? AND returns true if all the provided arguments are logically true. And then if any one of them is false, to bring out a false, right? So what is our argument? What are we saying must be true and must be false? The first thing we are saying must be true is this one must be equal to this one, meaning the names must be equal, right? Now, comma, we want to put the second logical equation. The second logical equation is telling us that since it's ARC n full we are doing, so n, so and it's basic access to water, n rounded we are using. So we want to also check if this one is equal to this one. So that's what we are doing. So you see that it brought in true or false. It brought in false because even though Afghanistan is Afghanistan, right? Even though Afghanistan is Afghanistan, right? But these two are not the same thing. If they were the same thing, if the basic access was 75, it would have brought in a true. Let me change it to 75 and you see how to change to true. It's already true. So now this is not what we want to do. We want it to be, if it's true, it should bring out a full access. If it is false, it should bring out an empty string. So how do we do that? We would have to include our if, which is, I feel like, is the most important tool in Excel, very versatile. So we'll put in if. We've done if multiple times. It takes in a logical expression. So what is our logical expression here? This is our logical expression. Because like you saw earlier on, it's bringing true or false. So if it is true, see value if true. So we'll put comma, it has moved to value if true. So if it is true, what do we want it to do? It should write full access. All right. So if it is false, what should you do? Empty strings. Thank you. So you see that we've clicked enter. It's giving us empty string because it is false. Let's see if we'll see anything. Okay, so this is full access. And you can clearly see what base n is 100%, what base z is 100% here. And if I go to the side, American Samoa. So yes, so you can see that that's working. But just like what we did here, the formulas would actually be the same because the name, we're still referencing the name. We're still referencing name here, Afghanistan, even if we are doing for, we did for national. Now, even if we want to do for rural, we are still referencing it. So we have to absolute something. The same way we did earlier, we have to absolute the name, the column, the A column, right? Because we don't want it to move through different columns if we take it to the side. So it will not go to B. We want it to stay on that A, but we want it to move downwards 3, 4, 5, like that. Now, this second one here, which is this what base n rounded, we're not going to absolute it. Why? Because we want it to, once it moves to this side, it will move to V, and V is the next one we want to use, which is the rural, right? What base R rural, and this is ARC R full. So this is the next one we want to use. So we will not absolute it. We will not even touch that up, but we want it to move. So let's absolute. I feel like I've been talking for too long. Are we clear? Are we following? Can someone?
Yes, we are following.
Another person, please. Do we have any question?
Yes, we are. Yes, we are good.
All right, thank you.
Do you want to drink water for 10 minutes?
No, let me just finish. I'm still at work, funny enough. All right, so thank you. All right, so what I need to do now is I would have to absolute, like I said, we need to absolute the, I've explained that before, the A column, right? But we're not touching this one because we want it to move. We want it to move to the other side when we take it to this side, and we also want it to move downwards. So let's just click enter. So once we've done that, we'll drag it down. Oh no. And then we'll take it to the side. So now we can be so certain that it has done what it needs to do. So this has gone. Oh, now I see my mistake. So what I did, you see that they're actually having the same value. And the reason why there's a mistake there is because what I did was I did what base n equal to this, but that's not what they told us to do. If you could remember, they told us to we should give full access if it is greater than 99% for both years. Greater than 99%, that's 100% for both years. So that's what we need to do. So we'll go back to our formula. There's a mistake, so we need to fix it. So what it's saying is this one, if this one is equals to 100, and then this one also is equals to 100, it should give us full access. So this is the AND formula. The AND formula will first check, are these two the same thing? They are the same thing, good to go. Is this one equals to 100? Is 100, fine. Is this one also equals to 100? Is also 100. So if those three things are correct, give us full access. So that's what we're doing. So we'll change this to U3 equals to 100, and then comma, U2 equals to 100, and then we'll click full access. So let me drag it down now. I think the formula is perfect now. So the beautiful thing about, if you understand your data appropriately, right, when there's a mistake, your body will tell you, like you know that something is wrong because you understand your data and you know what you should be expecting to some degree. You know what you should be expecting. I wasn't expecting to see same full access in the same place. So at that point, I knew something was wrong. So now, I'm balanced now. Looking at saying that okay, there's full access here, there's no full access here, there's no full access here. There's something is right somewhere, which is funny. I don't know why this is right because there's full access in the nation, but there's no full access in rural and urban. Okay, so but let's just double check our formula and see if it's making sense. So we're referencing A3. Ooh. So we're checking if A3. So we're checking if A3 is equals to A2. Fine. And then we're checking, once we're done checking that, we'll now come to U3 is equals to 100, and then U2 is equals to 100. If it is, then give it full access. If it is not, false. So this is not because it's not. So, and then let's check for the same one too. So it's V3 because it's what base R, and V2, fine. This one should be W3 and W2. Let's check Z, W3 and W2, and it's still A3 here, A3 here for the name column. So this is perfect. So let's look at this one. It's 100 obviously because now it makes sense. The reason why we didn't get anything there was because we had a null value. There was no value for these two, and that's the reason why we don't have. So ideally, this is how we should. If you understand your data, this is what makes logical sense. If a nation has full access, you would expect that the rural and the urban should have full access. The only reason why it will not have full access is because there was a null value, and that can replicate itself here. So now, or maybe there was, that's usually why it can't be. So see, full access. If it has full access in nation, it should have full access round. You see, it should have full access round. All these ones, the reason why it's not like that, no values. So it makes sense now. All right, back to our data. What did he say we should do? So we've done this pseudocode, moving past it. So create 2 more columns. We've done that in a beautiful fashion, actually. So now what do they want us to do next? They want us to calculate the numbers of country. We are calculating the numbers of country. We are calculating the numbers of country that their ARC value is equals to 0. So, but they don't have full access. So what this is basically saying is the ARC being 0, like I explained before, for example, let's say we have, see this one now, they are 90, is 97 and 97, right? 97 and 97, you expect the ARC to be equal to 0, right? Usually, something being 0, if something is to be 0, it means that what we've been doing since, if something is to be 0, it means that they are having 100%, right? And I told you earlier on that there are 2 reasons why the ARC will give you 0. The first reason being that they had maxed out their improvements. They are 100. They were 100 in 2015 and they are 100 in 2020. So for that reason, it cannot be more than 100. It cannot be, it will be 0 because 100 and 100 is 0. Another reason is if there was no change in 2015, it was 35. The government did not do anything to their water. In 2016 or 2018, the second year, it was also 25. So that way, so that is what this is calculating. So the first full access is calculating the one that is 100% confirm. That's full access. Now this one is now calculating the one that there was no improvement. So that's why they said ARC is equals to 0 that don't already have full access. So we are removing the full access from it and we're just bringing out ARC equals to 0, which is the ones that is not 100%, but there was no improvement. So we're doing that. Now we're doing the one that is not 100% and less than, there was no even need to even add all these ones to it because if you have full access, if you have full access, you would never have less than 0 ARC or greater than 0 ARC. It has to be 0, but that is what they want us to do. So we'll do what they want us to do. So we are doing 3 extra things. We'll access ARC value. We're calculating null. If we've calculated null, we'll calculate ARC value is equals to 0. Is equals to 0 and they don't have full access. The next thing, we'll calculate ARC value less than 0 and they don't have full access. And then ARC value greater than 0 and they don't have full access. So we can check for full access by using, so if you want to, this don't have full access, we're using the not equal operator, right? And this is what they want us to use, the COUNTIF formula. So COUNTIF formula, what does COUNTIF does? So COUNTIF So what does COUNTIF does? So COUNTIF, it counts cell that meet a certain condition. So for count, there's count A. Count A literally counts, it counts both numbers and text. Count counts only numbers. Count A counts numbers and text. There's count blank. Count blank counts only blank, right? And then we now have count if. So count if, you give it a range, you give it a condition, and then you count if, if the conditions are met, you count it. So no long term, when we start, we would see more. So they want us to use a COUNTIF formula to check out the full access and then do this one. So we can check that we have considered all the countries for the condition. No, so now if we've done all of these things they want us to do, so we can check for countries that do not have values, we can check for countries that have full access, we can check for countries that there was no change, we can check for countries that they had decline in their ARC, and then we can check for countries that there was an improvement in their ARC. And if we sum all of these 5 things together, we should get the total numbers of countries, right? Because that's literally everything. So let's go back to our calculation. So we'll come to the summary, about 4. So we'll come to the summary. When we come to the summary, initially they want us to calculate null. So let's just put ARC. Let me just all right. So we're doing null. We're doing full access. Ooh. We're doing ARC is equals to 0 and not equal to full access. This thing they want us to use. Not equals to full. Let me just put it this way. Just drag it down. So this one will not be equal to, it will be less than. We'll do for less than, and then we'll do for greater than. All right, so how do we calculate for null? We're using the countif formula. They've told us we'll use the countif formula. And what does countif do? For everything, we use it by using the countif. What does countif do? So countif, it returns a conditional count across a range. So meaning it would, you put in a range and then you put a criterion. So criterion means if the criterion is met, let's say you want it to count any place that it sees A. If that A is met, it will bring out the count. It will look through that range and bring out the count. If you say you want to count everything that is greater than 5, countif would look through all the ones that is greater than 5 in that range that you left, and then to count it. So in this our case, we want to count the one that is null. So what is going to be our range? So our range would be, come here, so our range will be this, and then we'll click. What just happened? Oof. So range, you come here, you pick this, and then if you see null here, count it. You click on enter. So 2. So now there's something I want to do because these ones are close to each other. After R is S and S is, I don't need to start doing the same thing for it. I'll just do this way to bring the result. You see that it has moved from R to S to T. So it has brought all the numbers here. So for full access, I can actually just drag down. Ooh, let me remove this one here. For full access, it's still the same thing, but rather than, oh, okay, for full access, this is what we are counting for full access. If we can remember, let's go back. So we had to do a different full access, right, to impute full. So this is where we are counting for these ones here are the ones we are counting for full access. So for this one, it to be X rather than R. I'll come here. I'll change it to X, or let's not even stress ourselves. Let's just, let me change it. Let's just do our count if again. So is equal to count if. So we're counting if from a certain range. The range will be this one here, because this is where we can see full access. We click in here, and then we write oh, because it's a string, we have to put that. I'm not sure what they call it. Maybe double quote or something. So we'll access, and then we'll close our double quote. Then we'll click on enter. So we have our value 62, and then we'll move to the side. It will equate because it's moving from, they are beside each other. So if it goes here to come here, so it goes here to come here. So he has done that. So the next one, this is the one we'll be using. If you remember, so what this one wants us to do is ARC is equals to 0, right? If ARC is equals to 0, it should also now calculate and make sure that it does not have full access. And they've told us what to use to say not. So this is what they use. This is the formula, the symbol they use to identify not on Google Sheets. So let's do. So it's the same thing. So count if, and the beautiful thing about now count if you notice when we click on count if, it says a range and criterion. But now you can see that there are two criterions now. The first criterion is, so if you want to use count if, you have to use and. You put an and inside, because there are two criterions you want to work with. The first criterion is its ARC is equals to 0, and then to go to a different column to check, are you sure that, confirm that it is not a full access as well. So those are two different criterions together. But with count if, you can only use one criterion and one range. So what you'll be using instead is count ifs, multiple criterions. So click on count ifs. So what's count if going to do? So to go through a range, so this is, it will go to a range. Which range is it going to? ARC is equals to 0. Let's come here. So it's because we are dealing with national. To go to the range, so that is the range. So what we want to do here is we want to check, because ARC is equals to 0, right? We want to check if there's 0 there. 0, yes, so 0. We want to check if there's 0 there. So that's the first criterion. So we've kept in the range. 0 would be the first criteria. Is the value here, is it equals to 0? So count if the value here is equals to 0. Now the second criterion would be, we put comma to identify that I want to move to the second criterion. The second criterion is we want to confirm here, because we are dealing with national, so it's still national full. We want to confirm here if there's no full access. So it's all these ones that does not have full access. That's what we want to. If there's full access, it's a false already, like that. It will not count it. But if there's no full access, it will count it. So what is it doing? It is counting when ARC, which is the annual range, is equals to 0, and also counting if the ARC national is full access and is not full access. So that's what they want us to do. So to identify it's not full access, it's still going to be, since it's a string, we're still using our double quotes, and then we're putting this here to signify full access. Please mind you, full access, you see the way I wrote full access before. So when I'm writing it here, I must not do the mistake. Access, capital letter. This is actually proper case. First letter will be capital, and then the remaining is lower case. Same thing. So this is a proper case. But anyways, that aside, access. So we've been able to do that. Then we click enter. So once we do that, all we just need to do is stretch it to the side, right? So we'll do the same thing for this one here. So for this one now, it's still the same formula. What will be the difference? The difference here will now be, you will notice that this one is saying less than 0. So we'll change this one to less than 0. Less than 0. And then this one is saying greater than 0. So we'll change this to greater than 0. Greater than 0. So the same way we are dragging, we'll drag this one to equate for every other one. And if you remember what he told us, he said the calculation of all this one like this should give us the total number of countries. So let's do total number of countries. Total number of countries. So I said it's going to be the calculation. So is equal to, and to that's sum. Sum. Sum this, 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 this. Enter. 231. So if you drag it like this, to give you the same, mind you, it's different formula. You can say that this one is C, this is D, this is E. So the reason why they are giving us is because everything we did here is correct. So the numbers of countries we have is 231. And if you can remember, if you look at our this thing, when I've been dragging down, the numbers of countries we have is 463, 462 actually. The one that made it 463 is because of this number 1 column here, that is the column name. So 462 divided by 2, which is, each country has 2 years. So that's 231. So this is correct. So we have 231 numbers of countries. All right. So we're done there. So this is the next one we're doing. We'll be able to. So the next one says, calculate the difference between the annual rate of change between rural and urban population per country. So we're calculating the difference between the annual rate of change between rural and urban per country. Okay, so each country wants to minus rural from urban. So what are we doing? We're creating a new feature, which is the ARC diff. In this data set, we are going to calculate the difference between rural minus urban for every second row, since these rows are empty. So we are doing for every second rows, since the first rows are empty. Right, so that's what they want us to do. Good. So remember, ARC and ARC rural and ARC urban are already in percentage. So the difference between them would also be in percentage. So we are aware of that. So we observe again value error. Let's go to what they want us to do. So this is what they want us to do. So ARC diff. I'm going to differentiate, demarcate all these things. Okay, I'm not sure if there was any. Okay, so what do they want us to do? So they want us to calculate this. And what does this do? Minusing ARC rural from urban. That's what it does. So it's minusing rural from urban for every second row. So that's what it does. So how do we do that? How do we do that? So now it could have been very easy. We could have just done, we can have just done is equal to this minus this, and we have gotten our value. But if you had done that, if we drag down, we are getting value here. This one is 0. And we're not supposed to get 0 here, because you can see that this place there's nothing here. And from what they told us, they said every second value, that's what we should have something. See, they said we should calculate for every second value since these rows are empty. So we're calculating this this one should have something, this one should have something, this one should have a calculation, this one should not have. So this is the tax we have to find. So now how would we be able to, so we have to think of how can we do it. So first of all, one thing that we can easily point out to is that it says second row being empty. So we can just create our formula in that direction, meaning that if this one is empty and this one is empty, don't calculate, just bring in an empty string. But if there's something here and there's something here, minus them from each other. So that's the formula we'll be doing. And then don't forget, we have to do something about this null so we don't have error. Even without, and I think they said something about it. So we should already be in the back of our head that if error should be everywhere because of this null. So that being said, so let's first start. So let's use AND first. So what does our AND want to do? It takes in logical expression, right? So if the two are true, then it is true. If one of them is false, then it is false. So what will it take? It's taking a logical expression. First of all, our ARC difference, you can see says ARCR, that's the rural ARC minus the urban ARC, the difference, that's what it wants to do. So first thing we need to do is check this one. Is it equal to empty string? This is empty string. Now check the second one too. Is it equal to empty string? Now that you've checked it's empty string, so if it is equal to empty string, bring another empty string. Like if it's check this one, is it empty? Check this one, is it empty? If it's empty, don't stress yourself. The first what I need to bring. So this is it's being true. If this thing is true, what should you bring? Empty string. But if it is false, what should you do? If it is false, what should you do? You should minus. Okay, so sorry, this is and, so we need if. So this and basically what does it do? It's this, is this empty? Is this empty? Bring true. If it empty, is it empty? Bring false. So if there's something here, and there's nothing here, is a false, right? If there's nothing like this one, and if there's nothing in both of them, is a true. So let's close our and first. So that's what our and is a joining. It's a joining operator, right? So we now need our beautiful if, the most versatile. So what would our if do? So our if, like we already been saying, it takes in a logical expression. So this is our logical expression. So if it is true, what value should you bring? So meaning and here, if S2 is empty and T2 is empty, there's no value in these two. That's a true statement. It should bring out what? An empty string. But if it is not true, then calculate, meaning there's something here, there's something here. Then calculate S2, S2. Let me just look for it so I'll be sure. Let me cancel this so I can see what I'm looking for. Okay, so just bring S2 minus U2. What's going on? Okay, T2. T2. And then we close our if. Now, so what have we been able to achieve right now? See our result here. This is fine. So what have we been able to achieve? We've been able to achieve that at this and. So basically, if there's something here, there's something here, you do the, so this is and, right? If there's nothing here, there's nothing here, you bring empty. If there's something here, there's something here. So it means this is the first statement. You can't do the empty again. You minus them from each other. So when you minus them, so that's the equation. But we need to factor in our if error just in case because of our null. So we'll put if error. So we'll put in error, if error. So if this is our value, so if it is true, to bring it out. Or if it is false, if there's error, if it calculates it and there's error, what do we want it to bring out? Null. So to bring out null. Then we click on enter. So that's what this is. So we drag to the end. So we've done our, let's now see what he wants us to do again. So we can observe, and we've dealt with our if error, our value errors, so we don't have value errors. So change the difference formula to account for error. So if we were to calculate the percentage difference, so percentage difference being, this is just the difference between this and this, right? It is already in percentage, right? We just minus it. So if you want to calculate our percentage difference, this is something, we did something similar in part 1 as well. So calculating percentage difference. So percentage difference will let us know what is the difference in percentage, like between the two changes, and it uses minus an average. So let's see. It says if we want to calculate the percentage difference, the absolute difference divided, it will be the absolute difference, absolute, take note, absolute divided by the average of the two. So in this case, what additional error would we have, and how are we going to do it? Is if error are using for anything, but I get what they're trying to say. So let's do percentage underscore ARC underscore diff. So not to go too far, what are we going to do? So we would first do, so what we want to do is, let's see. So if you say if this is equal to empty, it should bring empty, right? But if it is not equal to empty, what should it do? It should bring the absolute value. And the reason why we are doing absolute value of this is because this is the same thing as this minus this. So take note, see, absolute difference between the absolute difference. So that's difference. You are minusing this divided by, this is already the minus, but it is not absolute. You understand? And what does absolute do? So absolute, regardless of the symbol in front, if it's plus or if it's minus, it will convert it to plus. So that's what absolute does. So it makes everything positive. So what should we do? So this is what we are doing again. We'll click on this. So if this one, that's our ARC difference, if it's equal to an empty string, take note of our empty string because this is an empty string here. And our if, what does our if? It takes a logical expression. So if it is equal to empty string, what should you do? You should also bring an empty string, right? But if it is not equal to empty string, it has a formula. What should you do? It should absolute this one. We close our bracket because we want it to absolute this one, and then divide it by what? Average. Average of what? These two. Because this is what we are using. So this absolute here, this one that we absolute here is this minus this. So we'll do the average of this minus this. So average divided by average of this, then comma this. You can see average is showing us as we put the comma, it has shown us. So once we've done that, we click on enter. Have we accounted for everything? Okay, it remains one thing, our if error, because if we get to this null, it will give us an error. So we have to account for our if error. So if error, this is the value. So if there's error, what should you do? You bring null. So don't give us if error, just give us null. That's what we should do. So we click on OK. Now, what do? I think we're done. Double tap. We've gotten all our numbers. So what did he say we should do? So we've calculated this. So if we were to calculate the percentage difference, what additional whatever are we going to get? So we are to create an histogram for the newly created ARC div. This is the ARC div. So we have to create an histogram. So this is ARC div. Let me just demarcate it. So we have to create an histogram here for ARC div. Come here. Histogram. Ah, beautiful. You don't even have to stress. That's created our histogram beautifully for us. So like we usually do, we take it to a new sheet. So just by looking at this, you can also already, this looks very much like a, what's the word? A normal distribution. We kind of have like, not 100%, but it tries, other than all these outliers that we have here, but it tries to give that bell curve shape. So let's go on. We've done our histogram. We didn't even have to adjust anything because it was already, the histogram was already beautifully made. No need for adjusting beam or that's picked it appropriately. So what are we doing now? So now that we are done investigating by area, and then we've seen the difference between the rural population and the urban population. So this is ARC difference. So this is the difference between the changes of the rural. Abby, let's go. Let's see. ARC difference. What is it taking? S2. So the ARC for this and the ARC is minus it. So is the difference. So we've seen the ARC, so it's the difference between rural and urban. So because we are minusing rural from urban, no, because rural, because this is our rural minus urban. So if this gives a positive, it means that there was more change, there was more progress in the rural than urban. I don't know if I'm making sense. So if it's giving a negative, it means this value here is higher. So it means there was more progress in urban, and that's why when we minus it from this, it's giving a negative. I don't know if you guys are following and getting what I'm trying to say, but this minus this is showing that rural, as if this minus this and you have a positive, it means rural has, you know, is has more improvements than urban. This minus this, it means, and sorry, this minus this, and then you have minus, it means the urban is more than the rural. It's just normal calculation, and then we can see it beautifully in this graph, because like we said that positive means rural is more, has more improvement, and negative means urban has more improvement. So if you look at our charts, our histogram, you can see this is 0 here. You see that we have more values to the positive, and even the highest we have is a positive. So clearly we can say that there was more progress in the rural compared to urban, and which makes sense because most times urban, they've done all their progress already, so they don't need more progress. All right, I think I've so now we've done our histogram. Now we are doing what? We're investigating access by region. We're investigating assets by region, but we don't have region here. So how does the ARC compare across different regions? That's the first question we're answering. And then the second question is, what is the influence of national population size? Finally, we're using population size on ARC. So the UN often uses classification by region as a way of grouping various countries and investigate the region progress in the SDGs. We want to investigate whether more or less progress have been made in increasing access to basic water service in specific region across the world. So we want to investigate whether more or less progress has happened in different regions across the world. So what do they want us to do? So our original data set does not include region, obviously. So we have to amend our data set, amend meaning add to it. So we have to import our region CSV into a new sheet, add a new column to the original dataset called region, and then use a lookup function to add the region based on the country name. So we come here, we come to our dataset, we click on file, we import, go to my upload, go to browse, region. We'll click on region and then we open. It loads for a bit. Now this is tricky. We are not, this creates a new spreadsheet, is creating a new spreadsheet entirely. Insert new sheet means it's inserting a new sheet below here. Replace means everything you've done, it will cancel it. Okay, replace spreadsheet, so it will replace this whole spreadsheet. But if you replace current sheet, it means it will replace only this particular sheet. What are we doing? Append to current sheet, it means you are adding to it. We are not adding to it. So we are inserting a new sheet. So it will, instead of out this chart 2, chart 1, we have another region sheet here. So insert new sheet is a CSV file. So comma, we import. So we have our region. We have our region. So now that we have our region, they want us to add a new column in our original data set called region. And then we should use a lookup function to add the region based on the country names. So we come here, we have to create, let me just, so I have to create a new one called region. Right? So what does region do? So we'll use lookup. We'll use lookup. Oof. MCQ. So we'll use lookup. And what does lookup do? So there are different types of lookups, and we can always check it from here. First of all, let's do is equals to. Good. So there are different types of lookup. There's the first lookup. What does it do? So normal lookup, what does it do? So lookups looks through a sorted row. So very important, the row must be sorted. A sorted row or column. So row this way or column for a key. So this is the search key. So what you want to search for, that is the search key. So it looks through a sorted row or column for a key and then returns value of the cell in a result range located in the same position. So for example, look up, let's say we want to look up 100 now. So our search key will be 100 and then our range will be here because this is where we want to look it up. So it will look through here and then we can now specify where we want it to bring our result from. So if we want it to bring our result from this one, so it means that it will look through here and then it will bring our result from this one, right? So that's what lookup does. So lookup searches value in one column and returns matching value from another column. Emphasis on the matching. So it must be sorted though. Let's don't forget. And beautiful thing is in our spreadsheet, the very first thing we did was sort, right? So that's what a lookup does. There's another other lookup. It's called a VLOOKUP. So vertical lookup. So same thing, search key, range. But this one has index and is sorted. So for example, so what does it do? Vertical lookup searches down the first column. So it goes from first column to second column to third column like that for a range of key and then returns value. It returns the value of a specific cell in the row found, sorry. So now the range, we've talked about the range, the index would now be the first column is the index. So if you wanted to search from, so rather than we declaring what's it called, another column we wanted to search the results from, we can specifically just say, okay, start searching from the range I've given you, but column 2. So if this was the range, we can say column 1. So it will search, it will return from column 1. If you can say, if we want column 3, we write 3 to return from column 3. And then it's sorted, it just indicates whether the column you search for, the first column of the specific is sorted. So if it is sorted, we would write it sorted. If it's not sorted, we would write it is not sorted. So I think the beautiful thing about this is that it's sorted. So you can put it sorted and you can specify if it is sorted and you can specify if it is not sorted. So, but there's one I like using, which is the XLOOKUP. So this one is vertical. So XLOOKUP basically, so it searches. So there's a lookup range and then results. So it has many other formulas that we can look up to. So I'll be using the S and the XLOOKUP today. So what would the XLOOKUP do? So how are we going to use the XLOOKUP? So XLOOKUP, what will be our search key? Our search key will be, so like for example, if you come to our region now, we need to understand what our region is. Our region that's the data set we just added. Our region has a name here. So name is the name of the country. but now it's including the region for each of those countries. So what we are trying to do is we are searching for, so this is where we are getting our distance. So we are coming here, clicking here, right? So we want to get our, so we are searching these names. Where are we searching it from? We are coming to this region, we are searching it here, the A2, right? When we are done searching, we now want it to bring out, okay, I didn't put comma. So let's start again. So what are you doing? So is equal to x lookup. X lookup, you search where? What do you search? You search this one here. You put comma. Where are you searching? That's the search key. Where are you searching from? This is that one we click on. We want to search it from where? This one here. Right? You put comma. And what do we want to, which corresponding results do we want to bring? This is the corresponding result we want to bring. So once it checks Afghanistan from this, our initial sheet, and then it comes here, it sees that it's supposed to bring out the corresponding region here, which is South Asia. So we click here and we click enter. So let's see. You can see that it's bringing South Asia. So that's exactly what we wanted to do. Afghanistan, South Asia. So we'll just come down. So we've been able to fill everything now. So we're getting closer to the end. All right, so now that we've done that, what does it want us to do? So it wants us to go back to our summary sheet, and then we should do calculation. And what does it want us to calculate? It wants us to calculate the numbers of countries per region. So each region, we want to know the numbers of country, and then we want to know the average ARC change in national, and then the average ARC change in rural, average ARC in urban. So which Google function can do it? The easiest and the sweetest to do is a pivot table. It's so beautiful to use. So you just come here. This is our fifth. So what do you do? So you just come to insert in our menu bar, click on pivot table. So it's going to ask you, are we creating a new sheet or an existing sheet? It's an existing sheet. So what's our data range? Let's just put it here. Oh, let's just put it here. I made mistake. And then what is our data range? Like where is it taking the pivot from? Did you get the pivot? What is it pivoting? Is here. Everything here. So that's our main data set. Like this sheet. So click OK. We're inserting to the existing sheet. We've already done that there. And then we create. So the first thing it said is number of countries per region. So it means region, we want to see the numbers of countries. So the row would be our region. So row would be our region. Great. And then it wants us to numbers of country per region. So what would be our value? So value will be name. which is the number of country. So our value will be name, which is the number of country. But there's something that stood out that we should already know right now is that our countries are represented twice, right? So now that we are trying to find the region and country, it can't still be representing twice. So we have to make sure it should count. And that's when I was explaining all the different types of counts. There's counter, there's count unique. So count unique would, if it shows twice, it will just count it as once. That's what count unique does. So click on count unique. So now it's representing, and you can see that the total number of countries is 231, like we have said. So that's fine. So the next thing we want us to do is the ARC change for national per region, ARC change for rural per region. So it means our value will add ARC national, add more value, ARC rural, add ARC urban, but they told us average. So average, and then average. All right, the reason why we're having this here is because I clicked on all the entire sheet. If I had picked on the sheets I wanted itself, we won't have that error there. But this is what we're trying to find, so we shouldn't have much problem. This is what we're trying to find. So now we've done that. Any other question? So now they now want us to do one final thing. They said visualize access to region to investigate the relationship between the national and the urban annual rate of change, as well as the population size and region. So this is four different variables. So they want us to have a visualization that shows the difference between the relationship between national and rural annual rate of change. And then it also shows population size and then region. So what can we best use to address this? So what can we best use to address this? So now there are different types of visualization. And I think we did something about it. So there are different types of visualization to help show relationship, right? So you can visualization for comparison, you can visualize for composition, you can visualize to compare, like I said, you can visualize to find relationship. So now to find relationship, there are different visualization. You can use a scatter plot, you can use a bubble chart, you can use heat map. But scatter plot is best when you are using it for two variables, right? You have two variables, but this one is four, so you cannot use scatter. So for four, what you could use is bubble chart or heat map. So, but for this one, we'll be using a bubble chart. We'll be using a bubble chart. So we'll visualize, so create a visualization that represents the ARC versus the rural, as well as the region and population size. So do we observe any pattern? So let's create. So bubble charts is actually the best because we're doing four variables, right? Two numerical variable, three numerical variable, but these ones are in percentage. And then this other one, the population size, is the magnitude. So it can represent everything once without losing, its relationship. So let's just go straight to it and create our bubble. Let's go straight to it and create our bubble chart. Okay, so what are we using to create our bubble chart? So we'll be using national ARC. So where's national ARC? This is national ARC versus rural. And then we'll be using our region and then our population. Oh, okay. I've hidden the population size, so I need to unhide. Let me first unhide it. Okay, let's start again. So population size, ARCN, ARCR, and then region. So we are inserting the charts and then we are creating. So what chart are we creating? We're creating a bubble. We're creating a bubble. So this is a bubble. So they already told us what should be in our x-axis and our y-axis.
I have a question.
All right, please.
When you're trying to make a chart, in
Mhm.
selecting the columns that you're going to use to make the chart, is it very compulsory that you should not randomly select it, but you must select it based on the instructions? That if you should randomly select it, does it have any effect?
So we select the columns based off of what we are trying to represent. So that's what I was trying to explain earlier on. So sometimes the visualization we're trying to do might be a visualization of relationship. It might be a visualization of composition. Like you want to see how different parts make up a whole, right? Or we want to see like line chart now. Line charts, it helps to compare between, two variables over time. So we choosing our chart is based off of what we are trying to understand. So right now we're trying to understand based off of region, and we're trying to also compare based off of the ARC between nation and rural. So that's what we are trying to do. So there are still other charts that we can decide but to use, but which one of them is actually giving us the clear vision, like the clear picture that we're trying to look for, right? So this is the best one that can take all these things into consideration. So we could see our population with it. We could, compare our population to our ARC, national and rural, and then comparing it to region, right? So that's the reason why we're using this one. So you can create any chart you want to create, but you create chart based off of the information what you are trying to portray to your audience, what you want your audience to see, and that's why you create your charts, right? So we're trying to
Okay,
explain this, and that's why we're doing this one.
okay, I get that. But still, my question, I'm not still clear because maybe I have to select the same thing that you just selected, but randomly select them all, not in serial like you did. Maybe you
Okay,
select.
okay, I get what you're trying to say. So you can do it anyhow you want to do it, as long as those values are there. So it is here you now come to correct it. Do you understand? So,
Yeah.
so it is here. So for example, now I've not, you can see that though I've selected it and I've went try to create, it's not creating. So I have to now come here and in terms of size, I want to expect that the size, I mean, they already said it in our listing, right? That population size. So I want to believe population would be, I mean, it will be able to show population more. So I'll use this one as our population. I'll delete this one here. I'll remove this one. Our x-axis will be ARC. Our y-axis will be this one. Our x-axis will be ARCN. Okay, let me remove all of you. You're stressing me. So should give us our bubble chart now. Why is it not coming up? Column null must be selected. Column null. Oh, I mistakenly selected this. So let's Control Z. Let's Control Z. I mistakenly selected, delete this chart here. So that was the mistake. So this is what I'm selecting. Pop N, Pop N, this, and then the region. And then I'm inserting chat. Please mute. Um, then I'm going to my bubble chart, right? Okay, so this will be changed to ARCN. This is ARCR. This will be region, and then this will be pop n. Fine. So, like we usually do, we'll move to the end. So this is a beautiful chart. So with this now, we can, you know, clearly see, make some insights. You can easily see that the relationship between the national and the rural. So the x-axis, this is the national, the y-axis is the rural, right? So we can see that. So let's just, we can see that, for example, if you hover around this, you can see this is sub-Sahara. This is sub-Sahara as well. So sub-Sahara actually has, it has many points. Sub-Sahara is widespread, for example. There's sub-Sahara here, there's sub-Sahara here, there's sub-Sahara here, there's sub-Sahara here, there's sub-Sahara here. So sub-Sahara is evenly distributed. Contrary to what you might think that Africa, or we should be on the red zone. But what this is basically showing is that basically Africa is making progress at different scale. Or better say, sub-Saharan Africa is making progress at different scale, right? Even though we still have some bad eggs. For example, this one's here. They are bad eggs because it seems they are going backwards. They are not making any progress. But majorly, most of the Africans, they have more, sub-Saharan Africans, they have more progress towards this way. You can also see that this green one now, the East Asia Pacific also has one or two around the side, but majorly it has many. And you can see this blue one, the South Asia, slightly North America. Many of them are either they don't have change, or there's no change, or they are, there's progress. So they are clustering around the zero. This is zero, right? So there's small change, and that's because obviously you expect America and countries like that, Northern Americas, Europe and America, to already have good access to basic water supply. So there's really no much change because they were never in the rural zone before, um, as it's made. But yeah, so we can make and we can see that okay, South Asia is making progress. The person that has made the most progress in South Asia, you know, because maybe this one it used to be in a very dark zone before around this area, but they are developing in a very rapid scale, you know. So we have someone here. So there are so many ways you can, this way you can easily know that okay, which one are the high priority. The high priority, the place that WHO needs to focus more on the most is obviously sub-Sahara, because we still have some guys that are regressing, and then the East Asia Pacific. So they should focus more on these people. People like this South Asia, they're actually doing well now. Um, Europe, get wahala. So yeah, so that's, I mean, easily you can, surprisingly, not Middle East and North Africa are actually doing good too as well. We're not surprised, Isha, but Middle East and North Africa too, they have good relationship. So yeah, these are all the things you can even define, make more insight off of this bubble chart and the relationship. So I think that's so they just weaving arc into a story. So we have done an analysis of the data, calculating many different statistical measures and visualizing the data. But why does this matter, and how is it accountable? So we can easily see that sub-Saharan Africa, the home to the largest population in the world with limited access to water, is at the center of our finding. Despite some progress in recent years, sub-Saharan Africa will only have full access to water after approximately 280, by approximately 280. So they are saying, um, 54 years from now, that's when they would actually have complete progress. Wow. So this finding enables us to weave a powerful narrative about Africa's water crisis without significantly intervention. Without significant intervention, millions of Africa will face a scarcity of water, of clean water, for the next 60 years. So we need to focus more on that. So I think we're done. Um, Now this one is summary, what we should expect. You don't necessarily have to over around this. Let's just go straight to the MCQ. So for the MCQ, um, again, it's based off of what we've done, and I mean, it's subject to corrections, subject to, when you go back and look at it again, and you can devise or see something I missed or whatnot, and that will be fine as well. So just don't take it for. So let's just go straight to it. The first one says that. The first one says that true or false, right? The dataset provided represents the entire year range from 2000 to 220 for at least some of the countries. The dataset provided represents the entire year range. This word entire year range is saying is basically, to me, sounding more like 2000 to 2020, all the years was represented, but that's not what we saw in the data. So without wasting much time, we can say this is false. So number one is false. Now the next one is, what is the average year difference? Average year difference across the countries in our data set. We did average year difference. This is our summary. Average year difference. This is our average year difference, 4.8. So 4.8 is our answer for this one. The third one, it says, which of the following observation best represents the distribution of the year column? So the year column distribution, that's our first histogram. So this is our distribution. So which of them represents? Nothing can be said about the distribution because we have too few data. That's false. Distribution is neither normal nor negative nor positively skewed, since there are two distinct peaks. So this is the answer here. Two distinct peaks. Fine. So we don't need to check again since we've already seen our answer. Or let's keep going. Distribution is positively skewed, no. Negatively skewed, no. So the next one says, what is the average annual rate of change of access to basic water service for rural population? So average ARC for rural. Average ARC for rural. So we'll go to the chart. Average ARC for rural, 0.48%, because it's in percentage. So that's number 4. Number 5 states, how many countries' national population has a 0% annual rate of change, excluding countries that have 100%. Sorry if you Okay. How many countries' national population has a 0% annual rate of change, excluding countries that have 100% access across the time period? So we've done something like that. ARC is equals to 0 and not full percent. So how many countries? Let's go back again. How many countries national population has an 0% ARC, excluding countries? So this is it, national. So the answer is 16. The answer is 16. All right, number 6. Considering that the negative annual rate of change indicates a decrease in access to water from one year to another to the next, and then 0 indicates no change, which of the following statements is true based off of our data? Although access to basic water service on a national level remained unchanged for more countries than in the rural and the rural has the greatest decrease in access. Although basic water service on the national level remained unchanged for more countries than in rural and urban area, and then rural access had the greatest decrease in access. Okay, let's go to the next one. Although access to basic water services increased for more countries in the rural area than in the national, more countries had full access to basic water service in urban areas. I don't believe this is not correct. Most countries had a similar change in access to basic water across all population. This is not correct. Although access to basic water service on a national level increased for more countries than more countries had a decrease in access in urban than rural. Let me check. Decrease urban than rural. Okay. So the answer would either be this one or this one. So not so sure. Well, if I were to pick, I'll pick this one. All right. The next one is which two countries had the highest absolute difference between urban and rural? So absolute difference between the, sorry if you are speaking, mute.
Afghanistan.
So which two countries had the highest absolute difference between urban and rural annual rate of change? Okay, has the highest absolute difference. So that's our, we can easily just filter here. And then come here. Clear. This is the country that has the highest. Oh, it's two countries, sorry. So let me just pick the next one. So South Sudan and Morocco.
South Sudan, Morocco.
Guys, please mute. All right. So which two countries has had the highest absolute difference between urban and rural annual rates? South Sudan and Morocco. But he said, wait, hold on, let me check something. Okay, South Sudan and Morocco. That's the answer for number 7. So number 8, it says, which of the following statements is most true about the distribution of the difference in ARC value between rural and urban area? Rural and urban area, we did a visualization for that. This is its rural and so it's ARC difference. So rural and urban area. So what does it say? It says more countries had higher annual rate of change in urban areas than rural. This is false because it was on the positive side, and we said because the calculation was rural minus urban. So if it is positive, it means more of rural and then less of urban. So and then you can easily see this one now, 81 plus. So more countries had higher annual rate of change in the urban, so this is false. Annual rate of change were similar across, not similar, since the peak is close to the mid. Okay, were similar across normal, and since the peak is close to, okay. More countries had higher annual rate of change in the rural area than in the urban, since a greater number of different value fell to one side of the number line. We cannot say anything about. So for this, I will also either pick B or C here. The annual rate of change was similar across urban and rural areas for most countries, since the peak is near the middle line, or more countries had higher annual rate of change in rural areas than in urban areas, since a great number of difference value fell to one side of the number line. So, I mean, based off of what we've done, you can make your final, and when you go back to look through the materials and the videos, you can make your final decision. So this whole thing is just a guide, right? So the number 9 says, on average, which region saw the greatest improvement in access to basic water service on a national level, considering the annual rate of change over the I'm considering the annual rate of change over the dataset time period. So beautiful thing, there's a chart to tell us that which country saw the most improvement in the national. So this is it. Which region? South Asia. So South Asia saw the most improvement. Now number 10. Based on the visualization investigating the relationship between the rural and the rural national annual rate of change, national size and region, which of the following statements are true? Only countries in the sub-Sahara observed a decrease in the basic access. No, so this is a false statement, because we saw Sahara and then we saw East Asia. So they said the average population size per country in sub-Sahara is smaller than most regions. So I mean the size is how big the circle is. So the average is smaller than most regions. That's a true statement, because you can see all these big circles. This green has big circles, this blue has big circles, red has big circles, but Africa has small circles everywhere. The country in the sub-Saharan Africa observed a greater spread in rural and national than any other region. That's also true. Sub-Sahara, everywhere there was a greater spread. Yeah, even negative value here. So the countries with larger population generally observed national ARC value between 0% and 1. The countries with larger population, yes, you can see the big circles, they are between 0 and 1. So that's the true statement. So the answer here is B, C, and D. Thank you.